Welcome, dear friend, wherever you are, in the quiet of your room, on a long night drive, or maybe with your eyes closed drifting towards sleep. I want you to know this. You are safe here. This is your sanctuary of thought, a place where the mysteries of the universe unfold slowly, like a story told by someone who deeply cares for your curiosity. Tonight, we are going to explore something almost invisible, yet unimaginably powerful. A force that does not shine, does not burn, does not speak in the language of light, and yet it holds galaxies together. Without it, stars would drift apart, planets would scatter, and the very structure of the cosmos would dissolve into chaos. We call it dark matter. But before we begin, let me ask you, where are you listening from tonight? Do you feel the weight of the stars above you, or the comfort of a familiar place around you? Wherever you are, imagine this: the universe itself leaning closer, whispering its secrets into your ear. This journey won't be rushed. We will walk slowly, through story and science, through wonder and question. And as we go, I'll ask you to keep a small part of your mind open, for awe, for curiosity, for that childlike spark that once stared into the night sky and asked, "What's out there?" So take a deep breath, settle in, and let us step gently, together, into the invisible architecture of the universe. When you look up at the night sky, what do you see? Tiny glimmers of light scattered across a vast black canvas. Stars, planets, maybe the faint smudge of the Milky Way stretching across the darkness like spilled silver dust. To our eyes, it feels like we are seeing everything. The universe laid bare, infinite and complete. But here is the truth. What we see is only a fraction, a whisper, less than 5% of what actually exists. Imagine walking into a library where the shelves stretch endlessly, and yet the lights are on for only one narrow aisle. You might think that's all there is, a few rows of books, dimly glowing in the faint light. But in reality, the vast cathedral of knowledge around you remains cloaked in darkness. That is our universe. We see the glowing aisle, stars, galaxies, gas clouds, but hidden all around us is something larger, stranger, and profoundly more powerful: dark matter. The concept of dark matter begins with a contradiction, a tension between what we observe and what physics tells us should be happening. In the 1930s, a man named Fritz Zwicky looked at galaxies spinning in the Coma cluster. He noticed something deeply unsettling. The stars at the edges of these galaxies were moving far too fast. If the only thing holding them together was visible matter, the stars, the gas, the dust, then the galaxies should have flung themselves apart long ago, like water droplets spinning off a wheel. But they hadn't. They remained whole, intact, bound. Something unseen was holding them together. This was not an isolated puzzle. Decades later, Vera Rubin, an astronomer working tirelessly through nights of observation, noticed the same unsettling pattern. Spiral galaxies, like our Milky Way, were behaving as if there was an invisible glue binding them. The outer stars were orbiting at nearly the same speed as the inner ones, defying the laws of Newtonian motion if only visible matter were accounted for. It was as if the galaxies were sitting in invisible halos of mass, vast oceans of unseen substance that extended far beyond the glowing arms of stars. And here is where the poetry of the cosmos humbles us. We are blind to it. Dark matter does not emit light. It does not absorb it. It does not reflect it. To our most sensitive telescopes, it is silent. We only know it exists because of its gravitational fingerprint, the way it pulls, bends, and sculpts the visible world around it. Imagine a ghost walking through a crowded room. You don't see the ghost, but you notice the curtains sway, the floor creak, the glass of water trembling on the table. That is how we know dark matter is there. Now pause with me for a moment. Look around your room, your space, the very matter that makes up your body, your desk, the walls. This is baryonic matter, the ordinary kind, but floating invisibly all around you. Within this galaxy, within the room you sit in now, is dark matter. It is passing through you silently, ceaselessly. In fact, scientists estimate that trillions of dark matter particles pass through your body every single second. And yet, you feel nothing. Isn't that astonishing? We live inside a shadow ocean, and we don't even sense its touch. This leads us to a profound question. What does it mean to live in a universe where most of reality is hidden? Where all of human history, every story, every song, Every discovery has taken place within a bubble of ignorance, while the great majority of existence swirls unseen around us. Dark matter asks us not just to accept the mystery, but to live within it. To acknowledge that our senses, powerful as they seem, are woefully incomplete. That the universe has secrets so deeply woven into its structure that only patience, curiosity, and humility can reveal them. So, my dear listener, as you breathe in this thought, ask yourself, how do you feel knowing that the universe you trust, the universe you see, is only a shadow play on the surface of something greater? Does it make you feel small, or does it awaken a spark of wonder, a thrill that there is still so much to uncover? Because this is where our journey begins, with the acceptance that what we see is not all that exists, and perhaps the greatest truths lie hidden in the dark. Every great discovery begins with a discomfort, a nagging whisper that what we see doesn't match what should be. The story of dark matter is exactly that, a journey born from unease, from equations that didn't balance and galaxies that refused to obey the rules written for them. It started with the Swiss astronomer Fritz Zwicky in the 1930s. Picture him standing under the crisp mountain skies, peering through telescopes at the Coma cluster, a massive congregation of galaxies dancing together across space. To most astronomers of his time, it was a breathtaking sight, but to Zwicky, it was unsettling. He calculated the speed at which the galaxies within the cluster orbited one another. By all laws of physics, they were moving far too quickly. The visible matter, stars, gas, dust, was simply not enough to generate the gravitational pull needed to keep the cluster intact. It should have flown apart like marbles rolling off a tilted table. Yet there it was, whole and steady. So Zwicky proposed something radical. There must be an unseen substance adding weight, a hidden mass anchoring these galaxies in place. He called it dunkle materie, dark matter. At first, few listened. Zwicky was brilliant, but also known for being brash, often too abrasive for the scientific circles of his day. Many dismissed his idea as speculative, even eccentric, but Zwicky planted a seed, one that would quietly take root and grow decades later. The real turning point came in the 1970s, with Vera Rubin and Kent Ford. Rubin, a woman working in a field still heavily dominated by men, had already faced rejection and invisibility in her career. Yet her persistence was fierce. She turned her telescope toward the elegant spiral galaxies, whirlpools of stars drifting through the cosmic sea. Her measurements confirmed something astonishing. The stars on the outer edges of these galaxies were orbiting just as fast as those closer to the center. Now, let's pause. If you throw a stone on a string and spin it around, the stone on the end moves faster than one closer to your hand. That's how orbits work. Planets close to the sun move quickly, while those farther away drift slowly. But Rubin's data revealed the opposite. Stars on the fringes of galaxies were not slowing down. They were racing at speeds impossible to explain if only visible matter existed. This was undeniable evidence. Galaxies were sitting in vast cocoons of invisible matter, spherical halos surrounding them like unseen guardians. Rubin's work transformed Zwicky's forgotten suspicion into a scientific revolution. She gave dark matter legitimacy. What followed was an avalanche of evidence. Galaxy clusters, gravitational lensing, the cosmic microwave background. Each layer of observation whispered the same story. There is more mass in the universe than we can see, much more. In fact, nearly 5 times more. Yet here lies the paradox. While we can calculate its presence, while we can trace its fingerprints, we still have no idea what dark matter is. Scientists have proposed candidates: WIMPs, weakly interacting massive particles; axions, sterile neutrinos; theoretical particles that might drift unseen through space, colliding so rarely with ordinary matter that they leave no mark except gravity itself. But after decades of searching, we have yet to capture one in the act. And so, the hypothesis of dark matter remains both solid and mysterious. A theory built on overwhelming evidence, but still waiting for a face, a substance, a particle to call its own. Think of it this way. Imagine you are standing at the edge of a forest. You don't see the animals inside, but you hear the branches breaking, the rustle of leaves, the distant echo of footsteps. You know something is there, many things, but they remain hidden in shadow. That is how scientists feel about dark matter. Its presence is undeniable, its identity elusive. As we walk deeper into this journey, I invite you to hold on to this duality, the certainty of its pull and the mystery of its nature. In that tension lies one of the greatest scientific quests of our time. And maybe, as you're listening now, you can ask yourself, how does it feel to know that the universe itself keeps secrets, even from its most determined seekers? Does it frustrate you? Or does it comfort you? That no matter how much we learn, there will always be mysteries left, waiting to be uncovered, because that's what keeps the story alive. That's what keeps us searching. If you close your eyes for a moment and imagine a galaxy, what do you see? Perhaps a spiral of stars, glowing arms wrapped around a luminous heart, drifting in the endless sea of night. Galaxies look fragile, almost delicate, like cosmic pinwheels made of light. But here's the astonishing truth. What we see in a galaxy is not what holds it together. The visible stars, the nebulae, the golden clusters, they are just the ornaments, the sparks of a fire we can perceive. Yet galaxies are far heavier than they appear, and it is this unseen weight that reveals dark matter's quiet hand. Let's step back into the 1970s with Vera Rubin. Night after night, she gathered data on spiral galaxies, mapping the velocities of stars as they orbited their galactic centers. According to Newton's laws, the stars farther from the center should orbit more slowly, just as planets farther from the sun drift lazily compared to the swift Mercury or Venus. The math was clear. But when Rubin plotted the data, the universe refused to obey. The stars on the outskirts were not slowing down. Their velocities were flat, steady, even as distance increased. Imagine spinning a merry-go-round and seeing the children at the edge whirling just as quickly as those near the middle. Impossible unless an invisible hand were pushing them. This invisible hand is dark matter, a halo of unseen mass, stretching far beyond the starlit arms, binding the galaxy together with its gravitational embrace. Without it, galaxies would unravel. The spiral arms would fling their stars outward into the void. The delicate beauty of a galaxy would not survive a single cosmic heartbeat. It isn't just individual galaxies that betray this truth. Entire clusters of galaxies reveal the same secret. In the 1930s, Zwicky had already noticed that the Coma Cluster's galaxies were moving too quickly, as though an unseen mass were keeping them from scattering into the night. Decades later, gravitational lensing, the bending of light by massive objects, provided further proof. When light from distant galaxies passes through a cluster, it bends like glass, warping an image. The amount of bending reveals the cluster's true mass, and time and again, the visible matter falls short. Something vast, invisible, and undeniable must account for the difference. Now pause here. Imagine that you are floating outside the Milky Way, looking down upon it. The spiral arms glimmer with billions of stars, but wrapped around this glowing disk is a massive, invisible cocoon, the dark matter halo. It is spherical, stretching far beyond the edges, outweighing all the stars combined. In truth, the stars are just tiny candles floating in an enormous unseen lantern. This realization is humbling. What we love most about galaxies, their shimmering light, is only the frosting on the cake. The true structure, the true skeleton, is made of dark matter. Without it, galaxies would not exist as we know them. Every star you've ever wished upon, every nebula photographed in stunning color, every cosmic nursery giving birth to new suns, all of it rests within the arms of something unseen. And here is the almost poetic irony. We call it dark matter, but perhaps it should be called the silent giver. For it does not shine, it does not boast, it does not make itself known in light. Yet it allows the beauty of the visible universe to exist at all. So the next time you see an image of a galaxy, whether it's the majestic Andromeda or the soft sweep of our own Milky Way across a summer sky, remember this: you are not truly seeing the galaxy. You are seeing only the surface, the fireflies hovering above the grass, the field itself, the ground, the roots that nourish them. That is dark matter, hidden, essential. And maybe tonight, as you listen, you can hold this thought close. How many things in life are like this? How many invisible forces, love, memory, gravity, time, shape our lives without ever being seen? Perhaps dark matter is not just a scientific mystery, but also a metaphor whispered by the universe. That what is hidden can be more powerful than what is seen. The universe is a master storyteller, but it doesn't always speak in light. Sometimes it tells its stories through distortions, through curves, through the silent language of gravity itself. And in that language, dark matter reveals itself like a shadow cast on a wall, unseen directly, but impossible to deny. Let's begin with a thought experiment. Imagine you are standing beside a calm lake at dusk. You can't see the wind, but you know it's there because the water ripples and the trees bend. In the same way, we cannot see dark matter, but we see what it does. The ripples it sends through galaxies, the bends it carves into the fabric of space. One of the clearest fingerprints of dark matter comes from something called gravitational lensing. Albert Einstein predicted it in his theory of general relativity. Mass bends space-time, and bent space-time bends light. In other words, gravity is not just a pull, it is a sculptor of reality, warping the very stage on which the cosmic play unfolds. When light from a distant galaxy travels across billions of years to reach us, sometimes it passes near a cluster of galaxies along the way. Those clusters act like massive magnifying glasses, distorting the light and stretching it into arcs and rings. Astronomers call these Einstein rings. By measuring the degree of bending, scientists can calculate how much mass is present in the cluster. Here's the twist. The visible galaxies and gas in the cluster don't add up to the required mass. Over and over again, lensing reveals more bending than visible matter can explain. Something else, something invisible, is doing the heavy lifting. That something is dark matter. One of the most famous examples is the Bullet Cluster. Two galaxy clusters colliding, a cosmic crash frozen in space. X-ray images show hot gas, the visible matter, colliding and slowing down, while gravitational lensing maps reveal that the bulk of the mass has passed straight through, like ghosts refusing to interact with the chaos. The dark matter sailed on, leaving its gravitational fingerprint behind. This image became one of the most striking proofs of dark matter's existence, because it showed separation. The visible matter went one way, the invisible matter another, revealing the distinction between the two. But the universe gives us even subtler fingerprints. Cosmic microwave background radiation, the afterglow of the Big Bang, carries tiny ripples, fluctuations imprinted when the universe was less than 400,000 years old. Those ripples are shaped not only by ordinary matter, but by the hidden scaffolding of dark matter. Without it, the pattern of hot and cold spots would look completely different. Dark matter has been part of the story from the very beginning, weaving itself into the very birth cry of the cosmos. Think of it this way. Every child leaves fingerprints on glass windows. Every breeze leaves patterns on sand dunes. Every river leaves grooves in the rocks it passes. Dark matter leaves its marks too, not on surfaces we can touch, but on the fabric of the universe itself. And by following those fingerprints, we've traced its presence across billions of years and countless galaxies. Now pause for a moment and let this sink in. When you look at an image of the cosmos, a galaxy cluster, a swirling spiral, a cosmic web of filaments stretching across billions of light years, remember that what you are really seeing is not just beauty, but evidence. Evidence of something far greater than your eyes can grasp. Evidence that reality itself is shaped more by the unseen than the seen. And doesn't that echo something deeply human? Think of love, grief, memory, hope. None of these can be measured in kilograms or meters, yet they shape the course of every life. In a way, dark matter reminds us that the most powerful forces, cosmic or personal, are often invisible, revealed only in the way they bend the world around them. So the universe whispers to us through its fingerprints, and those whispers say, "You are living inside a story where most of the characters are still hidden in shadow." If galaxies are the glowing lanterns of the night, then dark matter is the invisible scaffolding that suspends them in place. But here's the wonder. Dark matter doesn't just hold galaxies together. It arranges the entire architecture of the universe. It weaves a web so vast that human imagination struggles to contain it. Let's begin with an image. Picture a spider web glistening in the morning dew. The silk is delicate, nearly invisible, yet every drop of water clings to its strands. The pattern is intricate, interconnected, spanning wide and holding firm. This is how scientists now believe the universe looks on the largest scales. A vast cosmic web, with dark matter forming the invisible strands, and galaxies gathering at the intersections like drops of dew. This isn't poetic exaggeration. It's a revelation drawn from computer simulations and deep space surveys. Astronomers have mapped millions of galaxies across billions of light years, And the pattern they trace is not random. Instead, it forms filaments and voids, rivers of galaxies flowing along invisible channels, separated by immense empty regions where almost nothing exists. But why this pattern? The answer lies in the early universe, just after the Big Bang. When the cosmos was still young, it was filled with tiny fluctuations in density, small clumps and dips of matter. Dark matter, unaffected by radiation in the way normal matter was, began to collapse into those clumps first, forming gravitational wells. Ordinary matter later fell into these wells, like water gathering in valleys carved by unseen hands. Over billions of years, those wells grew into filaments, and at their intersections, galaxies ignited. The cosmic web is therefore not just a structure, it is a history. It is the memory of how the universe grew from a nearly uniform soup of particles into the magnificent, interconnected lattice we see today. And dark matter was the silent architect, pulling the threads tight, shaping the flow of matter into the delicate design we now glimpse. Imagine floating in intergalactic space, far beyond the Milky Way. At first it seems like emptiness, vast stretches of nothing, but if your eyes could see dark matter, you would be surrounded by immense bridges and filaments stretching across unimaginable distances, connecting clusters like city highways in a sprawling metropolis. These filaments are hundreds of millions of light years long, yet they are woven with precision, balancing chaos and order in ways we still struggle to understand. This cosmic web also explains why galaxies are not scattered evenly across the universe. They are not dots sprinkled randomly, but glowing beads strung along invisible strings. If dark matter did not exist, galaxies would have formed differently, more sparsely, more chaotically. Instead, we find ourselves in a universe where structure emerges naturally, guided by hidden hands. And here's a thought that might stir something in you. You and I, everything we are, everything we love, sit inside one of these filaments. The Milky Way itself is part of the Laniakea supercluster, a massive region of galaxies all interconnected, drawn along the threads of the web. In other words, our home is not just the Earth, not just the solar system, not just the Milky Way, but a thread in an invisible tapestry billions of light years across. This perspective is both humbling and comforting. Humbling because we are so small within this grand design. Comforting because we are not isolated. We are woven into a vast, interconnected fabric, bound to galaxies millions of light years away by strands of matter we cannot even see. Now, reflect on this. If the universe is a web, then what role do we play upon it? Are we the dewdrops clinging to its strands, shining briefly before falling away? Or are we the eyes that finally behold the design, awakening to the realization that we live not in chaos, but in a hidden order? Dark matter reminds us that existence is not random, but sculpted, that in the silence of the void, there is structure, connection, and meaning. And perhaps, like the spider's web glistening unseen until morning light reveals it, the universe too is waiting for us to fully recognize the beauty of what holds it together. Every galaxy you have ever seen, in photographs, in telescope images, even the faint river of our own Milky Way across the sky, owes its existence to a silent architect. Without this hidden force, galaxies might never have formed at all. That architect is dark matter. To understand why, we must return to the early universe. Imagine a time just after the Big Bang. A sea of hot plasma, particles of light and matter colliding endlessly, too energetic and chaotic to clump together. Normal matter, the kind we are made of, was trapped in this violent dance with photons. It could not settle. It could not condense. It was like trying to pile sand in the middle of a storm, every attempt scattered by the winds of radiation. But dark matter was different. It did not interact with light. It was invisible to the storm. While ordinary matter was tossed and churned, dark matter quietly drifted, feeling only the tug of gravity. And gravity is patient. Dark matter began to gather into invisible clumps, forming what we now call halos. These halos became gravitational wells, deep valleys in the fabric of space-time. Billions of years later, those wells would serve as cradles for galaxies. Ordinary matter, cooled and freed as the universe expanded, finally began to fall into these valleys. Gas collected, condensed, and under immense pressure, ignited into stars. Thus, galaxies were born, not in isolation, but nurtured inside the invisible arms of dark matter halos. Think of it as scaffolding. If you've ever seen a cathedral under construction, you know that before the stained glass windows and the elegant spires can rise, there must first be a frame, a structure to hold it all in place. Dark matter is that frame. Without it, the Cathedral of Galaxies would have collapsed before the first star lit its flame. Simulations of cosmic evolution make this clear. When scientists run models of the universe without dark matter, the results are barren. Galaxies fail to form, structures remain thin and fragile. But when dark matter is included, suddenly the universe comes alive. Stars cluster, galaxies spiral, filaments stretch across the void. The invisible makes the visible possible. And here is the astonishing truth. Even today, every galaxy, including our own, still sits within its dark matter halo. You and I are living not just inside the Milky Way, but inside a vast, invisible cocoon of dark matter, stretching far beyond the stars we can see. That halo outweighs all the luminous matter by several times, yet it remains intangible, a silent sculptor holding us in its grasp. It also explains the diversity of galaxies. Small halos create dwarf galaxies, faint, tiny clusters of stars scattered like sparks. Larger halos nurture sprawling spiral galaxies or massive ellipticals, where billions of suns crowd together. The size and depth of the dark matter halo determines the scale of the galaxy it hosts. Without this invisible hand guiding the process, the universe would not carry the rich variety of galaxies we see today. Now, let's pause for a softer reflection. What does it mean that everything we love, our sun, our earth, every breath we take, exists only because of something we cannot see? Isn't that the most humbling revelation? That invisibility does not mean insignificance. Quite the opposite. The hidden, the silent, the unseen. It is often the most essential. Dark matter is not the star of the show. It doesn't shine, it doesn't dazzle. It doesn't appear in photographs, nor does it dominate headlines. But it is the stage, the scaffolding, the quiet hand that allows the stars themselves to perform. And perhaps there is a lesson there for us, too. Sometimes the truest power lies not in being seen, but in quietly shaping the world from behind the curtain. So, the next time you gaze at an image of the Andromeda Galaxy, or trace the Milky Way across the sky, remember, what you see is only half the story. The other half, the silent sculptor, is still there, cradling every star in a vast and invisible embrace. When we trace the story of everything back to its earliest breath, we return to a time when the cosmos was nothing more than a dense, hot sea of potential. 13.8 billion years ago, the universe expanded out of that first unimaginable moment, the Big Bang. In its infancy, it was pure light and energy, a radiant fog where matter had not yet taken form. Then, as the young cosmos cooled, the simplest elements, hydrogen and helium, began to crystallize out of the fire. These were the seeds from which stars would one day be born. But here is where the mystery deepens. When scientists looked at this story with the sharp eyes of their instruments, they found that something was missing. The numbers didn't add up. The young universe, so carefully modeled by physics, carried less visible matter than the galaxies we observe today would require to hold themselves together. If only stars and gas were present, galaxies would not have formed into the vast spiral and elliptical shapes we see stretched across the night sky. They would have unraveled long before our own sun ever had the chance to rise. It was as though the universe had written an equation but hidden half the solution. There was gravity where no light shone. There was cohesion where no ordinary matter could account for it. This unseen scaffolding, this silent partner, is what we now call dark matter. Without it, the great web of galaxies would never have come together. The night sky as we know it would be an emptier, lonelier place. Imagine for a moment, if you were to remove this invisible glue from the universe, the stars above you would no longer form the graceful river of the Milky Way. Instead, they would scatter like sand tossed into the wind. Clusters of galaxies, those colossal cities of stars, would never have formed. The cosmic architecture that allows us to even ask these questions would collapse into dust. This realization didn't come easily. For decades, astronomers wrestled with the idea. Could their measurements be wrong? Were the laws of gravity incomplete? Or was there, in fact, a vast ocean of invisible matter holding the cosmos together from the very beginning? The deeper we peer into the early light of the universe, the afterglow of the Big Bang, called the cosmic microwave background, the more evidence we uncover. Tiny ripples in that ancient radiation, still echoing across space, reveal that dark matter was already present in those first cosmic instants. It shaped the growth of galaxies, guided the flow of matter, and quietly orchestrated the grand structure of everything that followed. When you look at the night sky, you are not just looking at stars. You are looking at the visible embroidery stitched upon an invisible fabric. The missing mass, the dark matter, was there from the very beginning, a silent architect of creation, asking us to listen more carefully to the story written in the stars. Galaxies that shouldn't exist. When we look into the night sky, we don't just see points of light. We see cities of stars. Each galaxy is a colossal community, holding billions, sometimes trillions, of suns, planets, and clouds of gas. They are the great tapestries of the universe, suspended in the dark like glowing islands across an infinite sea. And yet, here lies the paradox. By every law of visible matter and every equation that we can write down, many of these galaxies should not exist at all. Let us begin with a simple act of imagining. Picture a spiral galaxy, perhaps one like our own Milky Way. Its stars are arranged in vast whirling arms, like the slow-motion unfurling of a cosmic flower. If you measure the light of those stars, if you add up all the luminous matter we can see, you can then estimate the gravitational pull those stars should create. According to Newton's laws and Einstein's refinements, this gravity should determine how fast the stars at the edge of the galaxy spin around the center. And here is the puzzle. When we observe the actual rotation of galaxies, the stars on the outer edges move far too quickly. They are whipping around the galactic core at speeds that should fling them out into the void. It's as if you tied a stone to a rope and swung it in circles, but the rope was far too weak to hold it. By all rights, the galaxy should tear itself apart. Yet it does not. The stars remain bound, orbiting endlessly as though some hidden hand is holding them in place. This realization came into sharp focus in the mid-20th century, through the careful observations of astronomer Vera Rubin. With patience and precision, Rubin mapped the rotation curves of spiral galaxies, measuring the speeds of stars from their bright centers out to their dim, ghostly edges. What she found astonished the scientific world. The rotation curves were flat. Instead of dropping off as expected, they stayed high and steady. This meant that something invisible, something not shining with light, was generating additional gravity, enough to hold the galaxies together. Rubin's work didn't just confirm a suspicion, it reshaped cosmology. Galaxies were not simply starry islands, they were embedded within vast halos of dark matter, spheres of unseen substance stretching far beyond the glow of starlight. Without this hidden mass, galaxies like the Milky Way could not survive. They would fly apart, their stars cast adrift into the night. Think about that for a moment. Every galaxy you've ever seen in a picture, every spiral swirled across a telescope's lens, every brilliant cluster is not just made of stars, dust, and gas. It is wrapped in an invisible cocoon of dark matter, a halo that outweighs the visible galaxy by a factor of 5, sometimes more. This unseen presence does not merely accompany galaxies, it defines them, shapes their structure, and makes their very existence possible. Now, let us walk further. Galaxies are not solitary. They gather into clusters, into colossal families held together by gravity. The Coma cluster, for instance, is one of the richest, holding thousands of galaxies in a single gravitational embrace. But here too, the visible matter tells a strange story. The galaxies within such clusters move so rapidly that they should scatter apart, fleeing into space like sparks from a fire. And yet the clusters hold. Something massive, invisible, is binding them. When astronomers first measured these motions, long before Rubin's work, they suspected there must be unseen matter filling the gaps. Dark matter was not just a galactic phenomenon, it was a cosmic one. And then, another layer of mystery emerged. Gravitational lensing, the bending of light by gravity, offered a new way to weigh the invisible. When distant galaxies shine their light across the cosmos, that light sometimes passes through massive clusters before reaching our telescopes. Gravity bends the path of the light, distorting it like glass bends an image. By studying the shape of these distortions, astronomers can calculate the total mass of the cluster, and time after time, the result is the same. There is far more mass present than can be explained by stars and gas alone. The clusters are filled with something dark, something unseen, outweighing the visible matter by enormous margins. This is where the poetry of the cosmos and the rigor of science intertwine. On one hand, the night sky inspires us with beauty, galaxies painted like brushstrokes across the black. On the other, it whispers of an invisible skeleton beneath that beauty, a scaffolding that makes the art possible. Without dark matter, the universe would be a different place. Galaxies would not hold, clusters would not bind. The great cosmic web, the interconnected network of filaments that stretch across the universe, linking galaxies into structures larger than imagination, would not exist. And yet, despite all this, we do not know what dark matter is. We can measure its effects with exquisite precision. We can map its presence across the sky. We can see its fingerprints in the afterglow of the Big Bang and in the motions of galaxies billions of light years away. But when we try to touch it, to capture it in the lab, it slips through our fingers like smoke. It does not shine. It does not absorb. It does not interact with ordinary matter in any way we can yet detect, save for the pull of its gravity. Here we stand then, at the threshold of knowledge. Galaxies, those luminous cathedrals of stars, are monuments to something we cannot see. They testify, silently but insistently, to the presence of dark matter. Their very survival is a riddle written across the cosmos, daring us to solve it. But perhaps there is also a lesson here, that reality is deeper than what meets the eye, that the universe is not a stage of obvious truths, but a layered mystery, where the brightest lights are stitched upon the darkest fabrics. So the next time you gaze upon an image of a galaxy, perhaps the Andromeda, spiraling in quiet majesty, or the Sombrero, with its luminous disk and dark lane of dust, remember this: what you are seeing is only the surface. Beneath the glow lies an ocean of the unseen, and without that ocean, the galaxy itself would vanish. Galaxies that shouldn't exist do exist, and they exist because the universe holds secrets more profound, more invisible, and more essential than we ever dared to dream. Close your eyes for a moment and imagine yourself leaving Earth. You rise above the oceans, past the blue curve of atmosphere, beyond the moon, the planets, the stars of the Milky Way. Keep going until galaxies themselves shrink into faint points of light scattered across the canvas of night. What do you see? Not randomness, not chaos. What stretches before you is something astonishing. An immense network, vast filaments of galaxies strung like threads across an incomprehensible void. This is the cosmic web. It is the largest structure in existence, a grand architecture that spans the universe. Galaxies are not scattered like dust in the wind. They are connected in a great lacework of filaments and nodes, immense clusters bound together by gravity. Between them lie vast, empty deserts of space, cosmic voids so empty that they contain fewer atoms than the faintest whispers of air on Earth. And woven through this entire tapestry, shaping its form, guiding its evolution, is dark matter, the silent sculptor. How do we know this? Astronomers have run simulations of the universe, powerful digital experiments that recreate billions of years of cosmic history. They begin with the conditions of the Big Bang, with the subtle ripples imprinted upon the cosmic microwave background, the afterglow of the universe's birth. Into these calculations, they add the invisible ingredient of dark matter, allowing it to tug and pull as it must according to gravity. And when the simulations play out, something extraordinary happens. The universe that emerges looks exactly like the one we observe through telescopes, a web of filaments, knots, and voids. Without dark matter, these structures would not form. The universe would be too smooth, too uniform, too featureless. But with dark matter, the invisible seeds grow into the vast, interconnected network we see today. Imagine the role dark matter plays. In the young universe, it gathered first, clumping together under its own gravity. Ordinary matter, hydrogen, helium, the stuff that can shine as stars, fell into the wells created by these dark matter clumps. Dark matter was the framework, the scaffolding. Ordinary matter followed, filling in the architecture with galaxies and stars, like light bulbs hung on an unseen grid. This scaffolding is not just theoretical. We can observe its outlines through gravitational lensing, when the light of distant galaxies bends as it travels through space warped by invisible mass. These distortions map the dark matter, like shadows revealing the shape of an object we cannot directly see. What emerges is a ghostly skeleton stretched across the cosmos, invisible to the eye, yet indispensable to the existence of everything. And here's where it grows even more fascinating. This cosmic web is not static. It evolves. Over billions of years, dark matter has continued to gather into denser regions, pulling galaxies toward one another, feeding clusters, building colossal structures that stretch for hundreds of millions of light years. One such structure is the Sloan Great Wall, a vast filament of galaxies so large it defies human imagination. And yet it is not unique. There are others. The Hercules Corona Borealis Great Wall, for example, over 10 billion light-years across. These are not merely clusters of galaxies. They are testaments to the shaping hand of dark matter, the architect of the universe's largest forms. What's most humbling is how delicate this balance is. If dark matter had been slightly different in its properties, if it moved too fast, for instance, the cosmic web would not have formed as we see it. Galaxies would not cluster, structures would smear out. The precise way dark matter behaves, cold and slow-moving, allowed the universe to weave itself into complexity. The stars you see tonight owe their positions, their order, to the whisper of invisible matter billions of years ago. This web also speaks to something philosophical. The universe, at its grandest scale, is not chaos. It is order, hidden, subtle, but profound. It is shaped not only by what we see, but by what we cannot. In some sense, this is a mirror of human life itself. The visible moments, the events we notice, are suspended upon an invisible framework of memory, of silence, of forces that guide us from beneath awareness. The cosmic web is not unlike our own web of thought and history, unseen yet holding everything together. Let us pause here. Imagine you are floating at a vantage point where you can see this cosmic web as though it were drawn across the sky. Filaments glowing faintly, galaxies glittering like dewdrops on invisible strings. You drift closer, tracing a filament, watching how it funnels galaxies into nodes, the massive clusters, the great intersections of cosmic traffic. And then, as you look into the vast dark voids, the emptiness between, you realize just how much dark matter must exist to knit such a delicate pattern in the first place. Every star that shines in your sky tonight, every flicker of starlight that ever guided a ship, inspired a poet, or sparked a scientist's imagination, is not alone. It is anchored, fixed in place by this hidden web. Without it, the stars themselves would be lost. What then is dark matter? A ghost, a shadow, a silent architect. We may not yet know its nature, whether it is a new kind of particle, a hidden force, or something beyond our imagination. But we know what it has built, and what it has built is magnificent. The cosmic web is perhaps the greatest evidence of dark matter's reality. It is not just theory, not just mathematics. It is written across the universe itself, in the largest structures we have ever seen. Galaxies exist not in isolation, but as part of this grand invisible lattice. And every one of those galaxies holds countless stars. And among those stars may be worlds, and among those worlds, perhaps, beings who also look up and wonder why their night skies shine as they do. So tonight, as you listen, consider this: the very fact that you exist, that Earth orbits the sun, that the Milky Way drifts in the cosmos, all of it is tied to an invisible hand. The web is not made of silk, nor of thread, nor of anything we can see. It is woven of mystery, stretched taut by dark matter across the deep. And though silent, though unseen, it speaks louder than any star. I am here, holding the universe together. If you were to gaze upon the Milky Way from afar, not from within, where we live, but from the quiet of intergalactic space, you would see a glowing disk of stars, a spiral of light turning gently in the darkness. Its arms would shimmer with blue-white suns, its core would glow golden, and faint dust lanes would ribbon across its face. But if you could look more carefully, if you could see not with eyes of light but with eyes of gravity, you would discover something far stranger. The Milky Way, and every galaxy like it, is not just a visible island of stars. It is immersed in an enormous, invisible halo, a vast sphere of dark matter that extends far beyond the edge of its starlight. These halos are the true bodies of galaxies. The stars, the gas, the glowing nebulae. All of that is just the inner decoration, a faint embroidery within the much larger dark matter cocoon. Imagine a soap bubble. The luminous galaxy is only the small glowing center, while the invisible bubble surrounding it holds most of the mass, stretching hundreds of thousands of light years into the black. We first discovered these halos not by seeing them directly. For how can you see what does not shine? but by tracing their fingerprints on the motions of stars. Vera Rubin's rotation curves revealed that galaxies do not spin as their visible mass would suggest. Instead, the stars at the edge orbit too fast, bound by gravity that must come from something unseen. The simplest explanation: each galaxy sits inside a halo of dark matter so massive that it outweighs all the stars within it. The Milky Way itself is believed to be wrapped in such a halo, containing perhaps 1 trillion times the mass of our Sun. That's more than 5 times the mass of all its stars, planets, dust, and gas combined. And our galaxy is not unique. Every galaxy, from the giant ellipticals that burn with hundreds of billions of stars to the smallest dwarfs with only a few million suns, is swaddled in a dark halo. These halos are not optional. They are the very reason galaxies can exist at all. Without them, stars would not remain bound. Spiral arms would never form. The grand designs we admire through telescopes would never survive the turbulent storms of cosmic time. Picture, for a moment, a small dwarf galaxy. Fragile, faint, barely glowing in the vast dark between giants. To the eye, it seems like little more than a scattering of stars. And yet, studies reveal that these dwarfs are among the most dark matter-dominated objects in the universe. Their halos are enormous compared to their visible light, like delicate seeds wrapped in thick, invisible shells. Without this unseen protection, these fragile galaxies would be torn apart by the tidal forces of larger neighbors. Dark matter halos are not static shells. They are dynamic, living structures. They form early in the youth of the universe, as dark matter gathers into clumps under its own gravity. These clumps merge and grow, swallowing one another, forming larger and larger halos. Galaxies fall into them like water into a basin, collecting at their centers, lighting up the halos with the glow of stars. Over billions of years, halos collide and merge too, dragging their galaxies along with them, shaping the dance of cosmic evolution. When you see 2 galaxies colliding, their arms twisted and stretched into tidal streams, you are also witnessing the merging of their halos, an invisible battle of giants shaping the fate of stars. But here is something even more astonishing. Halos stretch far beyond where starlight dares to reach. The visible part of the Milky Way is about 100,000 light-years across, yet its dark halo extends 10 times farther, perhaps 1 million light-years in diameter, overlapping with the halos of neighboring galaxies like Andromeda. In fact, the halos of galaxies are so vast that they often touch, forming a continuous web of invisible connections across space. Our galaxy is not a lonely island. It is a node in an immense invisible sea. We can even glimpse the outlines of halos through gravitational lensing. When the light of a distant quasar or galaxy passes near a closer galaxy, the unseen mass of the halo bends the light, magnifying and distorting it. These cosmic lenses reveal the hidden weight of halos, sketching their size and shape with eerie precision. Again and again, the result is the same. Halos are real, massive, and indispensable, and within these halos lies yet another layer of mystery. Astronomers believe that dark matter clumps within halos, forming subhalos, smaller concentrations that may host dwarf galaxies or remain completely dark, invisible to even our most powerful telescopes. Some simulations suggest that our Milky Way should contain thousands of these subhalos, most of which we have never seen. They may be entirely dark, silent satellites orbiting our galaxy, gravitational phantoms that stir the motions of stars without ever shining themselves. This idea raises a tantalizing possibility. Perhaps the universe is filled with invisible galaxies, objects made almost entirely of dark matter, with no stars to light them. Entire ghost galaxies may drift unnoticed, detectable only through the way they tug at visible matter. If true, then what we see, the glittering spirals, the bright clusters, is only a fraction of the real population. The cosmos may be haunted by unseen giants. The halos also whisper secrets about the ultimate fate of galaxies. For instance, the Milky Way and Andromeda are on a collision course, set to merge in about 4 billion years. This dance is not just between stars, but between halos. Long before the disks of the galaxies touch, their halos will already be colliding, overlapping, pulling at each other, shaping the future remnant. The galaxy that emerges, a vast elliptical, bloated and brilliant, will be the child not only of starlight, but of dark matter's invisible grip. Even our solar system is embedded within this halo. As Earth circles the Sun and the Sun circles the galaxy, we are also moving through dark matter, immersed in the invisible sea of our galactic cocoon. Every second, trillions of hypothetical dark matter particles may be streaming through us, silent and unnoticed. And though we cannot yet detect them directly, their presence is undeniable. Without them, we would not be here. There is poetry in this. We think of galaxies as glowing spirals or bright clusters, but the truth is deeper. Their visible beauty is only the surface of a greater whole. They are like lanterns floating within invisible spheres, their light held steady by an unseen hand. The halos are the real galaxies, and the stars are only their glowing hearts. So next time you look at a picture of the Milky Way or Andromeda, imagine the vast, unseen sphere that surrounds it. Imagine the trillion suns worth of invisible matter cradling the delicate spiral within. Imagine the halos of neighboring galaxies touching, blending, weaving into the greater fabric of the cosmic web. And then realize this: without these halos, the night sky above you would not exist. The stars you love, the constellations you trace, the very Milky Way arching overhead on a dark night. All of it depends upon this invisible embrace. The halos remind us of something profound, that what we see is never the whole story. The visible is always suspended within the invisible, the luminous within the dark. And perhaps in some way, our own lives reflect this truth. Our brightest moments, our visible selves, are also wrapped in halos of memory, of silence, of unseen forces that shape who we are. Dark matter halos are not just scientific curiosities. They are the cradles of galaxies, the cocoons of stars, the invisible womb of cosmic creation. To ignore them is to miss the very foundation of the universe's architecture. They are the reason galaxies can exist at all, and thus the reason we can look up tonight and see a sky filled with stars. Time is not only something we measure, it is something we speak, even when we do not know it. Every culture, every age, has carved its own metaphors into the flow of seconds and centuries. Some whisper of it as a river, endlessly flowing towards some distant sea. Others call it a wheel, spinning through seasons, births and deaths, endlessly repeating itself. Some imagine it as a ladder, where every rung is a year, and every ascent leads closer to something transcendent or final. But beneath all these symbols is a deeper truth. Language itself is trapped inside time. Without time, there is no sentence, no pause between words, no rhythm for meaning to take root. And yet, as we describe time, we also distort it, bending it into whatever shape comforts us most. Think of clocks, our mechanical lighthouses that shine across the fog of confusion. When humanity built its first clocks, they were crude and irregular, sundials that bowed to the mood of clouds and seasons. Time was once fluid, uncertain, like shadows that lengthen and shorten with the turning of the earth. But then, with gears and pendulums, with quartz vibrations and atomic pulses, we began to trap it, slice it, imprison it into rigid segments. Seconds, minutes, hours, boundaries imposed on something that never truly had them. And yet, the deeper you look, the more those boundaries begin to dissolve again. An atomic clock, capable of losing less than a second across millions of years, still reveals something unsettling. That time itself is not constant. In the mountains, it moves faster than in the valleys. On airplanes, it stretches differently than on the ground. Gravity bends it, speed reshapes it. The same clock ticks differently depending on where it rests, reminding us that time does not belong to clocks. It belongs to the universe itself, and the universe does not care about our neat divisions. Now think of shadows. They are the oldest language of time, a wordless script written on the ground by the sun. Long before civilization measured hours, people watched shadows crawl across stone, tree, or body. A shadow was a reminder of presence, of movement, of passing. Even today, when we rarely notice them, they whisper to us, everything is shifting, everything is leaving, nothing stays. A shadow at dawn is not the same shadow at dusk. Even the act of standing still carves a map of time upon the earth. But here is where the language of clocks and shadows grows strange, perhaps even dangerous. Shadows remind us that time is not entirely ours, while clocks convince us it is. The two tell different stories. One speaks of cycles, eternity, recurrence, while the other speaks of progress, deadlines, endings. One says, "You are part of the sky." The other says, "You are running out of minutes," and trapped between them. We live lives torn between cosmic rhythm and artificial urgency. If you listen closely, you may even hear the hum of a deeper language, one that no clockmaker designed and no shadow wrote. Physicists have tried to glimpse it, the hidden code behind entropy, the subtle bias that nudges events forward. This language is not numbers, but probabilities, a strange poetry that says, order decays, heat spreads, the arrow flies one way. Time is not truly a line, nor a circle. It is a push, a drift, a leaning toward change. And here is the most haunting question. If clocks and shadows are just metaphors, then what is the real shape of time? Is it something we can speak at all? Or is it beyond speech? Something that slips out of language the moment we try to grasp it? Perhaps time is not a noun, not a thing, but a verb. Something happening, something doing. And if that is true, then maybe we are not moving through time at all. Maybe time is moving through us, like breath, like wind, like a shadow across the ground. The clocks keep ticking, the shadows keep crawling, but behind them both, an invisible truth hums, one that neither the sun nor our machines can fully capture. And perhaps, if we ever learn to hear it, we will no longer need clocks or shadows or even words. Memory is the only rebellion we have against the silence of time. Think about it. Every second vanishes the moment it arrives. Every gesture, every breath, every word spoken is instantly consumed by the abyss of the past. And yet somehow we refuse to let it go. We hold fragments, impressions, entire lifetimes inside our minds, as if they were stones gathered along the banks of a rushing river. Memory is not just remembering, it is an act of defiance, a refusal to allow time to erase us completely. But memory is not a faithful servant. It does not preserve the truth, it distorts it. It bends under the weight of emotion, reshapes itself under the hand of longing, decays with the passing of years. What you remember is not what happened, but what your mind has decided to sculpt from the ruins of experience. And so, in the very act of resisting time, memory becomes time's ally, a trickster that convinces us we have captured the past when all we are holding are shadows, half-truths, ghosts. Yet even ghosts matter. They matter because they give shape to identity. Without memory, there is no self. You would wake each morning as a stranger, lost in a body you do not recognize, wandering a life without anchor. Memory chains us to continuity. It tells us who we were yesterday, so that we can imagine who we might be tomorrow. In this sense, memory is the bridge between past and future, the single thread that allows us to pretend time is linear, coherent, and meaningful. But here is the great paradox. Memory does not move at the same pace as the clock. Sometimes years vanish in a blink, collapsing into a single sensation. The smell of rain, the taste of childhood fruit, the sound of a long-dead voice echoing in your head. Other times, a single moment stretches endlessly, burning itself so deeply into your mind that you can never escape it. The clock insists that an hour is always 60 minutes. Memory whispers otherwise. An hour can last a lifetime, or it can dissolve into nothing. And scientists, in their sterile laboratories, have begun to uncover what poets always suspected. Memory is not a library of books stacked neatly on shelves. It is a living, breathing storm inside your brain, neurons sparking, paths reshaping themselves each time you recall something. To remember is to rewrite. Every act of memory alters the memory itself. What you carry with you is not the past. It is your last remembering of the past, tinted by who you are now. This means that time does not only erode reality outside of us, it erodes reality within us. The more we try to cling to memory, the more it slips, reshaped, polished, corroded. And yet we cling anyway. Why? Because without memory, we would have no rebellion at all. Consider this. Civilizations themselves rely on memory. History is collective memory, recorded and retold, carved into stone, pressed into paper, digitized into the vast servers of our modern world. But history too is fragile. Empires burn libraries, floods wash away archives, languages die, taking with them the very ability to recall. And so humanity's memory is as unstable as our own minds, subject to distortion, manipulation, decay. Every history book is both rebellion and lie. Every monument is both truth and propaganda. Time erodes, and we patch the ruins with stories. Now imagine this. If memory is the only rebellion against time, What happens when time itself begins to rebel against memory? Consider the moments you cannot explain, where you are certain something was different, certain a detail has shifted, certain that the world has rearranged itself behind your back. Some call it déjà vu, others call it the Mandela effect. Perhaps it is only the mind misfiring, but what if it is not? What if memory is not failing, but fighting, resisting, clawing against the edits of reality itself? Maybe time is not smooth. Maybe it fractures, splits, rewinds, corrects itself. And maybe memory is the scar left behind when it does. You remember something the world no longer agrees with, and the dissonance rattles your bones. In those moments, you are witnessing the silent war between memory and time, and you feel the tremor of something bigger than yourself, something hidden, something they do not want you to know. Because here is the dangerous possibility. If memory is not simply a rebellion but a weapon, then perhaps it can cut through time's illusions. Perhaps by remembering deeply enough, vividly enough, stubbornly enough, we can hold pieces of reality that time tried to erase. Perhaps memory is not just survival, it is resistance. And maybe this is why memory hurts, why nostalgia burns, why grief is unbearable. To remember is to fight against time, and fighting is always painful. Every memory you carry is a wound that never closes, a wound cut by the blade of time itself. But it is also proof that you are more than the present moment, proof that you are not just a leaf carried by the current. You are also the hand reaching back, refusing to let the river sweep everything away. So, when you sit quietly at night and memories rise like ghosts around you, do not curse them, do not call them torment, see them for what they are. Your rebellion, your secret resistance, your refusal to let time win. The clock ticks, the years dissolve, but memory whispers, not yet. Not everything, and perhaps in the end, when the clocks stop and the shadows vanish, memory will be the last flicker of rebellion that remains, the ember that refuses to go out, even in the dark silence where time itself finally surrenders. We like to believe that time is simple, don't we? A straight line, beginning, middle, end, past behind us, future ahead of us, present beneath our feet like the step of a stairway. But the deeper we look, the more that staircase shatters, the more the line fractures, the more the clean symmetry of time dissolves into something stranger, something untrustworthy. Physics tells us this, though it whispers in equations most never see. Time does not behave the same for everyone. It bends, it slows, it stretches. The faster you move, the slower your clock runs. The closer you drift toward immense gravity, the more the seconds dilate, expanding like elastic pulled too far. Einstein showed us this with relativity, and his equations have been proven again and again by satellites orbiting Earth, by astronauts in the silence above us, by particles accelerated to near light speed. Time is not one universal rhythm. It is a fractured song, different in every place it plays, and that is only the beginning of the fracture. For when physicists stare at the quantum world, the hidden machinery beneath reality, they find something even stranger. At that smallest level of existence, particles seem to ignore time altogether. They do not move from past to future in orderly steps. They blur, they exist in possibilities. Sometimes they even behave as if the future has already reached back and touched the present. Cause and effect, the sacred law of time, begins to unravel at that scale. But the fracture goes deeper still. Have you ever wondered why time flows forward at all? The laws of physics do not demand it. Equations describing the motion of particles, the evolution of galaxies, the spread of light, most of them would work just as well if time flowed backwards. Symmetry should reign. Yet in our lived reality, it does not. We cannot reverse the shattering of glass. We cannot unburn fire into wood. We cannot unbreathe the last breath of someone we love. Why? The answer, or the illusion of one, lies in entropy, the tendency of systems to grow more disordered with time. This arrow of entropy is what gives time its direction. Eggs scramble but do not unscramble. Smoke disperses but does not gather again. Memory forms in one direction only. You remember yesterday, not tomorrow. The symmetry is broken, fractured, but no one truly knows why the universe began with such astonishing order in the first place. Order that could then unravel. Why was the cosmos born with such low entropy? That question remains unanswered, lurking at the heart of time's mystery. Now pause with me here. Think of your own life. Have you not felt this fracture? Days when time accelerates, slipping away before you can grasp it, and nights when it drags unbearably slow, stretching like an endless desert. The symmetry of time inside us is just as broken as it is in the cosmos. Trauma makes moments eternal. Joy makes them vanish too fast. Time is not one experience but a million, fractured by perception, shattered by emotion, splintered by consciousness itself. And what if, just what if, this fracture is not a flaw, but a clue? What if the cracks in time's symmetry are not imperfections but windows? Windows into the hidden architecture of reality. Each fracture reveals that time is not absolute, not unbroken, not the single unyielding river we were taught it to be. Instead, it is a mosaic of currents, some flowing faster, some slower, some circling back. Some physicists whisper of multiverses, parallel realities branching at every fracture, every choice you do not make spawning a world where you did, every particle that shifts a different way, creating a new timeline. If that is true, then time is not linear at all. It is a fractured crystal, each shard reflecting a different story, a different you. But here's the unsettling part. If reality is truly fractured, then the version of you listening now is only one fragment. Somewhere else, you are not listening at all. Somewhere else, you never found these words. Somewhere else, your entire life shattered in a way you cannot imagine. Does that disturb you, or does it liberate you, knowing that time is not one prison, but countless labyrinths? The fracture is not just cosmic. It is personal. You are living proof of it. Every memory you hold is one symmetry broken. Every scar you carry is a fracture where time carved a mark that cannot be erased. And yet, here you are, whole enough to notice the cracks. Perhaps that is the secret. Time is not meant to be perfect. It is meant to break. It is in those fractures that we find meaning, beauty, story. The symmetry of time was never complete. It was always destined to shatter, so that consciousness could slip into the cracks and begin asking the questions you are asking now. And maybe, just maybe, if you listen closely enough to those fractures, you will hear not chaos, but harmony, a deeper rhythm pulsing through the broken symmetry. A song older than the stars, playing not in straight lines, but in shattered mosaics. The song of time, imperfect and infinite, waiting for us to finally hear it. From the moment humanity first understood that time was not just a word, but a force, an invisible river carrying us from birth to death, we have dreamt of escaping its grip. Stories of time travel are as old as myth itself. Gods who rewound the sun, prophets who glimpsed the future, visions of endless return. Deep down, we have always sensed that the flow of time might not be as strict as the ticking of a clock suggests. And the truth is, modern science does not shut the door on these forbidden pathways. It leaves them cracked open, just enough for possibility, and perhaps danger, to slip through. Einstein's theories were the first real spark that set this dream aflame. If time slows down near light speed, if gravity itself bends time, then the rigid march of seconds is not absolute. Already, we have created time travelers, though we rarely call them that. Astronauts aboard the International Space Station orbit Earth at tremendous speeds. When they return, they are a fraction of a second younger than they would have been had they stayed on the ground. Minuscule, yes, but real. Time has bent for them. The forbidden pathway has been walked. But physics, as always, is more daring than our imaginations. In the equations of general relativity, there exist solutions, exotic, almost terrifying solutions, that allow for time loops, closed time-like curves, as they are called, where one could travel forward and find themselves looping back into the past. Wormholes, if they exist, might serve as tunnels not only through space, but also through time. Some physicists whisper of cosmic strings, immense threads of energy stretching across the universe that could, under the right conditions, bend time like paper, folded in half. Of course, these possibilities require energies and materials that border on the impossible. Negative mass, exotic matter, stellar-scale engineering. To us, they feel like fantasy, but fantasy has a strange way of becoming reality. Electricity, flight, space travel, all were once absurdities. Stories whispered around campfires. Is time travel any different? Or is it a truth waiting patiently for us to be brave enough or reckless enough to seize it? And yet there is a shadow cast over this dream. Paradox. The word itself drips with unease. Imagine you step back in time and prevent your own birth. Who then went back? Or picture yourself whispering a secret into your younger ear, a secret that guides your entire life. Who spoke it first? The younger you or the older you? Time seems to rebel against such violations. The paradox is the universe's way of defending itself, of slamming the door shut, just as we begin to pry it open. But perhaps paradox is not a wall. Perhaps it is a signpost. Some thinkers suggest that the universe self-consistently protects itself, that even if you travel back, your actions cannot alter the flow in ways that create contradiction. If you try to stop an event, you will only end up being part of the cause that ensures it. You cannot kill your past self. You can only fulfill the story that was always written. A terrifying thought, is it not? That even with the power of time travel, you are still shackled to fate. Others propose branching timelines. Every decision, every paradox, every interference creates a split. You do not destroy the past. You simply enter another version of it, another branch of the multiverse. This would mean there are infinite versions of you, infinite histories, infinite futures, all fracturing out from each forbidden step taken across time. And if that is true, then somewhere, right now, another version of you has already made the leap, already tested the forbidden pathway, already succeeded, or failed. And here lies the silence they do not want you to notice. What if we have already achieved it? What if time travel exists, but its ripples are disguised as anomalies, misremembered histories, impossible coincidences, déjà vu, the Mandela effect? Perhaps the fractures in memory are not flaws in our minds, but scars of interference. Perhaps the evidence is already around us, hidden in plain sight. If time travel is real, then history is not fixed. Every empire could have been undone 1,000 times, only to be restitched in another branch. Every war might have ended differently. Every love story rewritten, every death reversed. Our world, our present, could be the survivor of countless invisible edits, countless forbidden intrusions. And the fact that we feel something is off may be the only clue that we are not walking the original path at all. Now imagine what that means for you, sitting here, listening. What if your most private memory, the one you cling to, the one that defines who you are, what if it is a remnant of a different branch, a different world, one that was erased by a traveler you will never meet? Would you still call yourself the same person? Would you still believe your past belongs to you? Time travel is the forbidden pathway because it forces us to confront the fragility of reality. If it is possible, then nothing is secure. Identity, history, even cause and effect, all are vulnerable. And maybe that is why the truth, if it exists, is guarded so carefully. For what happens when humanity, reckless and impulsive, gains the ability to rewrite its mistakes? Would we heal ourselves or destroy ourselves faster than time could ever manage alone? So I leave you with this. When you dream of time travel, are you dreaming of freedom or of control? Do you wish to return to heal your wounds or to bend destiny to your will? The forbidden pathway is not just a question of physics. It is a question of morality, of humility, of whether we are wise enough to step into time's broken corridors without tearing the entire house of reality down upon us. Because maybe the real reason time keeps its pathways hidden is simple. It is protecting us from ourselves. The clock, that simple circle with two hands that has sat in every room of our lives, from childhood bedrooms to hospital walls. We trust it, we obey it, we measure our worth by it. Early, late, punctual, wasting time, saving time. Yet the clock, for all its precision, is nothing more than a trick, a fragile illusion built to tame something untamable. Because the truth is, time is not what the clock tells us. Time is not neat, not uniform, not obedient. Behind the steady tick, tick, tick lies a chaos, a mystery, a silence they would rather you never hear. From the beginning of this journey, we have seen that time is fractured, slippery, resistant to symmetry. We have seen that memory rebels, perception bends, and the universe itself refuses to play fair with the seconds we cling to. But here, at the culmination of our first topic, lies the deepest truth. The clock is not counting time, it is counting us. Every tick is a heartbeat. Every second is a reminder of your mortality, your fragility, your fleetingness. Time itself may be infinite, but the span you are given within it is not. The clock is your mirror, and it is whispering, you are temporary. And yet here is the paradox. Though the clock tells us we are fragile, we also sense that something in us escapes it. You know this feeling. You felt it when you lost yourself in music, when you stared at the night sky and forgot the ticking, when you held someone's hand and felt eternity in a single breath. These are the cracks where the illusion slips, where the clock's tyranny falters, where the last secret of time begins to reveal itself. Because maybe time is not just an external flow. Maybe it is a field, an ocean, a fabric, And consciousness itself is what ripples through it, what shapes it, what resists its collapse. Physicists chase this with equations, the possibility that time is not fundamental at all, but emergent like waves rising from a deeper sea of reality we cannot yet perceive. Some even suggest that time does not exist outside of our perception, that the universe is a frozen sculpture of all events, past, present, and future, already carved into being. In this block universe, the flow of time is nothing but a trick of perspective, a way for consciousness to walk the corridors of an already completed house. If this is true, then you are not moving through time. Time is moving through you. But here's the question that gnaws like a splinter. If all of time already exists, if the future is as real as the past, then where is your freedom? Do you choose, or do you only discover what was already written? The clock then becomes more than a tool. It becomes a cage, a reminder that you are playing out a role in a script too vast for you to see. And that is the last secret they don't want you to notice. The more you search for time's truth, the more you risk seeing that you may not be as free as you believe. And yet, listen closely. The fracture, the rebellion, the paradox, the dream of travel all point to something else. Maybe freedom is not about escaping time, but about how you live inside it. Maybe the only way to defy the clock is to stop measuring life in seconds and begin measuring it in meaning. A single second can be eternity if it is filled with presence. An entire year can be wasted if it is lived in absence. The clock does not define you. You define the clock. So as we close this first great topic, as the hands of your own clock tick onward, I want you to ask yourself, what are you doing with the time you have? Are you letting it slip like sand through clenched fists? Or are you daring to open your palm and see how the light shines through every grain? Because maybe, just maybe, the last secret of the clock is not despair. It is liberation. The moment you realize that time is not against you, not hunting you, not caging you, but simply asking you to be awake, to be alive, to be present in the fleeting miracle of now. And perhaps when you embrace that, you will see what no physicist, no philosopher, no hidden hand could ever fully erase, that the mystery of time is not meant to be solved. It is meant to be lived. There are nights when the cosmos feels like a locked room, and we, fumbling by candlelight, press our faces to the keyhole. We know something is on the other side because the floorboards creak and the air shivers. We can't see it, but its weight is measured in the way galaxies spin and light bends. For nearly a century, the best answer to that pressure, that tug, has been a particle, or perhaps two kinds of particles, that refuse to show themselves. Among a crowded suspect list, two names stand out like those who would most easily have the motive and the means. The WIMP and the Axion. They are the frontrunners in a cosmic whodunit. First, breathe in this framing. Science often proceeds like a courtroom drama. Evidence piles up and the courtroom grows loud. Some theories are accused and exonerated. Others linger under suspicion for decades. Dark matter's evidence is the gravitational behavior of the cosmos. The suspects must explain it. They must be plentiful enough, cold enough, slow-moving at the time structure began to form, and able to produce the cosmic web we map across the sky. The candidates are judged by whether they fit not just one clue, but the whole pattern. Reviews of the field, exhaustive, careful, and updated as the hunt advances, place WIMPs and Axions at the center of this case because they explain a swath of observations and because they are testable in laboratories and observatories. WIMPs, weakly interacting massive particles, are, in a sense, the textbook suspect. They are heavy, slow, and shy. They do not feel the electromagnetic force, which means they don't shine or absorb light. They speak only through gravity and, if we're lucky, the weak nuclear force. There is a seductive line of reasoning that produced WIMPs long before the experiments were built. The WIMP miracle. If a particle with weak-scale interactions and mass on the order of tens to thousands of GeV existed and froze out from the hot, early universe at the right time, its relic abundance would naturally match the dark matter we infer from galaxies and the cosmic microwave background. It was elegant, almost too tidy. It offered a particle that fit cosmology like a glove. That logic inspired a generation of detectors and experiments, and shaped decades of effort. So the laboratories were built, and the hunt began deep underground, where the world is quieter and cosmic rays do not chatter. Tanks of liquid xenon, cryogenic crystals, enormous time projection chambers, searching for the faintest recoil, when a WIMP might bump an atomic nucleus. These detectors grew in size and sensitivity with each generation, Xenon 1T to Xenon T, Lux to LZ, Pandax and others, and they peeled back layer after layer of parameter space where WIMPs could be hiding. Each null result was not a failure so much as a fingerprint. It told us which rooms and closets are empty. The experiments have constrained WIMPs across a wide mass range and pushed the allowed interaction strengths to ever smaller values, ruling out the simplest and most natural WIMP models. In other words, the neat miracle has been squeezed. If WIMPs are the culprit, they are not the ones we first imagined. This slow narrowing is itself a story of devotion. Imagine armies of scientists and engineers, years of funding, gargantuan refrigerators, and painstaking background rejection, all to capture the whisper of a particle that might pass through a wall of lead and ignore it. Every new upper limit set by Xenont or LZ is a kind of victory in understanding, even as it tightens the noose on the original WIMP hypothesis. Those null results change the tone of the hunt. Where once we expected a simple detection, we now regard WIMPs as either rarer, lighter, heavier, or interacting through strange, less direct couplings. The search continues, not because hope is blind, but because science follows the map of the unknown until the last cave is searched. Opposite WIMPs in character, axions are quiet in a different register. They were born not out of cosmological yearning, but out of an internal mathematical discomfort in particle physics, the strong CP problem. Physicists noticed an absence of a certain kind of symmetry, breaking in the theory of the strong force, a puzzle that, when solved a certain way, called forth a new particle, the axion. Later, cosmologists discovered that such axions, produced in the early universe via mechanisms like misalignment, could behave as cold dark matter if their mass and coupling fell within specific windows. The axion is an elegant solution with two virtues. It not only could be dark matter, it could also solve a standing problem in quantum chromodynamics. Two birds with one carefully tuned stone. But how do you catch an axion if it barely mutters? They are expected to couple extremely weakly to photons in magnetic fields. That coupling is the key to the haloscope, a laboratory-sized conversion. Place a resonant cavity in a strong magnetic field, tune the cavity to the right frequency corresponding to the axion mass, and then, if the axion bath that pervades the galaxy is right there, quantum mechanical rules allow axions to convert into faint microwave photons you can detect. It is an exquisitely technical idea, stoic in its patience. Tune, listen, and repeat, scanning mass ranges over months and years. Experiments like ADMX and a growing family of resonant searchers, including cavity haloscopes and new broadband approaches, have pushed sensitivity into some well-motivated axion parameter space, and the field has seen a resurgence of interest and technique in recent years. These efforts have transformed axions from elegant speculation into an experimental frontier. So we have two prime suspects with different temperaments. The WIMP, robust and heavy, once exalted by theory, and now constrained by null results, and the axion, shy and light, whose elegance binds cosmology and particle physics, and whose detection demands patient resonance. Between them lies a broader landscape: sterile neutrinos, dark photons, self-interacting dark matter, primordial black holes, and a new menagerie of particles and fields that theorists have summoned as the experiments closed some doors and opened others. Reviews of the field in the last few years have emphasized that dark matter is not likely to be a single solution problem. The resolution may require creativity and interdisciplinarity, new detection channels, and even new physics beyond the standard searches. If you imagine the search as a map, the X-ray glow of the cosmic microwave background and the pattern of galaxy clustering are the contour lines. They tell us where mass resides and how it must behave. Those cosmological constraints insist that dark matter be cold, or at least behave cold on relevant scales, and be present in the right abundance. That narrows the field of suspects, but it does not name the criminal. Particle physics, laboratory experiments, and astronomical searches each contribute a set of constraints, and sometimes they contradict one another in beautiful ways that force refinement of theories. For instance, astrophysical signatures like small-scale structure can hint whether dark matter is warmer or self-interacting, and precision laboratory limits tell us how strongly it can couple to ordinary particles. Reconciling both sets of data is the art of the hunt. There is a human warmth to this chase. It is not only a game of detectors and equations, it is a multi-generational obsession. People build instruments that will not likely see results in their lifetimes. They hand off the baton to the next team. They write careful papers that others will read decades later. The field changes course slowly, like a river carving new banks. The WIMP-driven era taught us how to build ultra-clean, ultra-sensitive detectors. Those technologies, though they have not yet captured a WIMP, are invaluable, opening paths to search for lighter dark matter and unexpected signals. The Axion Renaissance taught experimentalists to be patient and elegant in their scanning. Together, these approaches have widened our experimental imagination. Yet the melancholy of the current chapter cannot be ignored. Year after year, the simplest WIMP models recede into smaller parameter spaces, and the likelihood of a near-term, dramatic, single experiment detection of a canonical WIMP diminishes. That does not mean WIMPs are dead, far from it. But the character of the search has changed from an expectation of relatively imminent discovery to a sustained, meticulous siege. Meanwhile, Axion searches are accelerating, benefiting from technological cross-pollination. Microwave engineering, precision quantum sensors and cryogenics all contribute to unprecedented sensitivity. The community adapts, as any good investigator should, following the clues where they lead rather than where they would prefer. There are also aesthetic tensions at play. The WIMP solution was attractive partly because it fit the scale of known physics. It felt like an extension rather than a revolution. Axion's demand we accept a tiny mass and feeble couplings, a more delicate addition to the particle zoo. Other proposals are wilder still, dark sectors with their own forces and particles, interacting feebly with ours. Macroscopic compact objects like primordial black holes, or emergent phenomena where dark matter is not a particle at all, but an emergent behavior of a deeper field. Each proposal carries philosophical implications for what it means to discover dark matter. Are we hunting a single particle, or are we listening for a chorus? There is something tender in imagining these possibilities. The cosmos may be more coy than we hoped. It may have layered its secrets in subtle shades, so that only tenacious, diverse probes can reveal them. Telescopes mapping gravitational lensing and the cosmic web, underground detectors listening for nuclear recoils, radio cavities attuned to whispering axions, and even astronomical anomalies that might hint at self-interaction or new dynamics on galactic scales. The hunt has broadened precisely because nature has not obliged a tidy answer. We must widen our imagination without losing our rigor. If you ask, as I ask you now, what should we feel at this stage? Frustration or both? Frustration because a grand simple answer remains elusive, or because the orchestration of human ingenuity and from the mountain caverns that house xenon vats to the delicate cavities cooled to whispering, fractions of a degree above absolute zero, is a testament to curiosity itself. There is nobility in the refusal to surrender. Every null result is also a lesson, each limit a map showing more clearly where not to look and thus where to focus next. The cosmos is stern, but it has not yet been unkind. So how will this drama resolve? We cannot say. The scales may tip toward axions, or a WIMP lurking beyond our current reach may finally be cornered. Or perhaps the solution will be something unexpected, an exotic dark sector signal, a subtle astrophysical phenomenon misinterpreted, or a breakthrough instrument that finally listens in a new way. The one thing we can say with confidence is this: the evidence will decide. The sciences that stitch together particle physics and cosmology are built to correct themselves, to refine hypotheses, and to adjust priorities as new data arrives. Until then, the hunt continues, patient, rigorous, and full of wonder. And now, before we step from the prime suspects into the next corridors of evidence and method, hold a quiet image in your mind, a great night sky vault, glittering with galaxies, each wrapped in an invisible shroud. Within that shroud might lie a heavy, solitary WIMP passing silently through our world, or a flood of delicate axions humming faintly like a cosmic radio station. Or perhaps the truth is stranger still. But whatever it is, we will look for it, not because we are sure we will find it, but because not looking would be worse. To remain uncurious in a universe full of mystery would be the deepest loss. If you've ever looked up at the night sky and felt as though something vast was pressing against you from beyond the stars, you were right. There is something there, something enormous, something invisible, something that does not shimmer or blaze or glow. It does not announce itself with light, yet it outweighs everything we can see. It is called dark matter, and though we cannot touch it or trap it in our instruments, it shapes the universe itself. Astronomers began suspecting its existence when galaxies refused to behave. Picture a spiral galaxy, arms stretched wide, spinning like a pinwheel. According to the laws of physics as we knew them, stars at the edge should drift slower, like planets orbiting the sun, but they didn't. They moved too fast, so fast they should have been flung away into the void, their galaxies torn apart. And yet galaxies held together, spinning in defiance of what our equations predicted. It was as if an invisible hand was gripping them tight, anchoring them against disintegration. That hand was dark matter. We do not know what it is. That is the haunting part. It is not atoms, not protons, not neutrons, not electrons. It does not glow in any wavelength of light. It does not collide, does not scatter, does not burn. Yet it exerts gravity, and in doing so, it sculpts reality. In fact, dark matter is thought to make up about 85% of all the matter in the universe. Imagine that. Everything you see, every star, planet, person, and particle is only a thin film, a faint shadow draped across a structure of hidden mass. Think of it like this. If the universe were a painting, the stars and galaxies are just the brushstrokes, but dark matter is the canvas beneath, the silent surface that gives form to everything else. Without it, galaxies would scatter, stars would drift alone, planets would never form, and life, your life, would never have emerged. Scientists call this web of hidden matter the cosmic scaffolding. Using computer simulations, they trace its presence. Vast filaments of dark matter stretching across space, weaving galaxies like beads on a string. The visible universe is only a decoration hung upon this unseen structure. If you could peel away the stars and gas, the dark matter web would remain, a ghostly skeleton holding everything in place. But here is where the mystery deepens. Dark matter may not simply hold the universe together. It may also connect time itself. Some theorists whisper that dark matter interacts with forces we do not yet understand, forces tied to the very arrow of time. Could it be that the universe's hidden mass also acts as a hidden clock, subtly influencing the way entropy unfolds? Could it be that time, that invisible current we chase, is braided with dark matter's unseen grip? And then, an unsettling thought. If dark matter holds the universe, then what holds dark matter? Does it have its own shadow, its own deeper fabric we cannot yet name? Are we gazing at only the second layer of a reality that hides countless more? When you look into the night sky, you are not only looking at stars, you are looking at what is not there, at the gaps between light, at the silence behind the shine. Dark matter whispers from that silence. It tells us that the universe is far stranger, far deeper, far more haunted than we ever imagined. And maybe, just maybe, it is not as far from you as you think, because you too are moving through it right now. Every step you take, every breath you draw, is surrounded by an invisible ocean. Dark matter is not just out there in the sky. It passes through you, through your walls, through the earth beneath your feet, like an endless tide of shadows. We live inside a cosmic web we cannot see. And the most chilling truth of all, that web may not just be scaffolding. It may be a script, a hidden lattice where not only galaxies, but destinies are strung. Imagine standing in a room where every clock ticks, every pendulum swings, every heartbeat beats in rhythm with a rhythm you cannot hear. A rhythm older than the galaxies, deeper than the fabric of light itself. This is what scientists are beginning to suspect, that time, the very thing we believe flows evenly, smoothly, like an invisible river, may actually be bent, guided, and whispered to by dark matter. Let's begin with what we know. Gravity bends time. Einstein showed us that when mass is present, space and time warp around it. Near a black hole, time slows so dramatically that an hour for one observer might be years for another. If dark matter makes up most of the universe's mass, then it is not just shaping galaxies, it is shaping time itself. Not just where we are, but when we are. Now pause for a moment and let that sink in. Every particle of dark matter surrounding us, every invisible tide washing through your body at this very second, may be subtly bending the pace of your life. Time as you feel it, your memories, your choices, your unfolding story, may not be entirely your own. It may be braided with the invisible gravity of something we cannot see. The web of dark matter is not uniform. It pulls in halos around galaxies, it stretches in filaments, it thins in cosmic voids. That means time itself is not uniform either. Imagine the universe not as a flat ticking metronome, but as a vast drum where some places beat slower, deeper, heavier, while others ripple quick and light? Could it be that in one region of the cosmos, entire civilizations evolve and collapse in what would be a blink to us, while in another, aeons stretch and drag like honey dripping through eternity? Some physicists even whisper that dark matter may interact with the arrow of time, that one-way push from past to future that entropy demands. We don't fully understand why time flows forward. The equations of physics don't require it. They work perfectly well backward. Yet in our world, the glass shatters but never unshatters. The fire burns but never unburns. The dead do not rise and breathe again. Time insists on moving forward. Could dark matter be the hidden enforcer of that law? The silent governor that makes sure the arrow never falters? But here's where the speculation turns stranger still. There are hints, subtle, fragile hints, that dark matter may not only influence time but may itself be a form of time. Consider, if dark matter cannot be seen, cannot be touched, cannot be detected directly, but only felt through its gravitational pull, could it be the shadow of a deeper dimension? A dimension not of space, but of duration. What if dark matter is the residue of moments themselves? A fossilized echo of time's unfolding, scattered like ashes across the cosmos. Now imagine this. When you breathe, you are not only moving through air, you are moving through a current of unseen matter, woven from the same mystery that carries your hours away. When you dream, when you remember, when you ache with nostalgia, you may be brushing against the fabric of this invisible field. Perhaps the reason memory feels heavy, why longing feels infinite, why time's passage can feel so uneven, is because consciousness itself is sensitive to the tides of dark matter, like a sail trembling to a wind no eye can see. And if dark matter bends time, what of dark energy, the even stranger, more mysterious force that is accelerating the universe's expansion? Could it be that dark matter and dark energy are two sides of the same coin, one binding time, the other stretching it, together weaving the rhythm of all existence? If so, then everything you have ever experienced is not simply your life. It is the universe pulsing through you, dragging you forward, holding you together, erasing you, and remaking you in each passing instant. Now I want you to ask yourself, how much of what you call your time is really yours? If every clock you own is only a dim reflection of an invisible web that spans billions of light years, are you not simply a note in a grand cosmic symphony? Your tempo set not by will, but by gravity and shadows. This is the secret. Time bends to the dark, and you, every breath, every heartbeat, every passing day, are bending with it. If dark matter sculpts the galaxies, if it bends time itself, then surely it must touch us here on Earth. And yet, how rarely we pause to consider it. We wake, we work, we eat, we sleep, convinced that the minutes we carry are ours alone. But all the while, something unseen flows through us, wrapping the planet in its gravity, saturating our bodies like water saturates a sponge. And perhaps, just perhaps, the reason time feels different to you in different moments, why hours vanish when you laugh, why days drag when you grieve, is not only because of your mind, but because of the dark tides that pass through us. Let's begin with the simplest truth. Earth does not sit still. Our planet races around the sun at 67,000 miles per hour. The solar system itself hurtles around the center of the Milky Way, weaving through spiral arms, plunging into denser and thinner currents of dark matter. Every second of your life, you are not standing in one place. You are swimming through oceans of matter that do not shine. And if dark matter bends time, then your seconds are not constant. They stretch and contract, subtly, invisibly, like breaths. Some physicists believe that as Earth moves through the galaxy, it may pass through streams of dark matter left behind by ancient cosmic collisions. These streams could act like invisible rivers, tugging on us, altering the tempo of time itself. Imagine, somewhere on Earth, perhaps tonight, perhaps tomorrow, time ticks just slightly differently, ever so slightly bent by the whisper of this passing tide. It sounds impossible, but think of the atomic clocks, the most precise instruments humans have ever built. They do not lose even a second in millions of years, and yet, even they detect differences. Clocks tick faster on mountains than in valleys. Clocks tick differently on plains than on the ground, all because gravity bends time. If visible matter bends time so measurably, what of the invisible sea we cannot see? A sea that outweighs everything else. Now step deeper. What if consciousness itself is sensitive to these tides? What if the way we feel time, the way our memories arrange themselves, the way dreams flow, are not only products of neurons and synapses, but subtle harmonies with the passing waves of dark matter? Could this explain why ancient cultures built calendars and monuments not just to track the sun, but to align with the stars, to listen to rhythms deeper than daylight? Perhaps they sensed, in ritual and silence, the pull of something modern physics is only now beginning to glimpse. And here is where the thought becomes haunting. If dark matter is everywhere, if it flows through us, then it is not only sculpting galaxies, it is sculpting history. Civilizations rise and fall, wars are fought, revolutions ignite, discoveries unfold, all within the invisible heartbeat of a force we cannot see. If time itself bends to these tides, then perhaps the ages of the world, the eras we so neatly carve into textbooks, are themselves the echoes of shadow currents. Humanity may be not just a maker of history, but a passenger swept along its unseen river. And then there is the personal. Have you ever had a moment that felt eternal? A kiss, a loss, a sound, a silence, seconds that stretch so wide they feel like they could contain the whole universe. Or the opposite, a day so fleeting it dissolves like smoke. Perhaps these are not illusions, perhaps these are real. Perhaps when you felt time slow, it was not only your mind, it was the bending of the fabric itself, pulled by the hidden mass of the cosmos. This means you are never alone in your minutes. When you wake in the morning, you rise not just into sunlight, but into a tide of dark matter flowing through your body. When you fall asleep, you drift not just into dreams, but into the hum of currents that shaped galaxies before Earth was even born. Every second you live is braided with the dark, and the dark is not silent. It is a rhythm, and the most unsettling truth. You have no way to step outside of it. You cannot shield yourself from it. You cannot build a wall against it. Dark matter flows through your bones, your brain, your blood. It passes through the walls of your home as though they were nothing. You are porous to it, as fragile as mist in its ocean. And if it bends time, then time itself does not belong to you. But maybe, just maybe, that is not a curse, but a gift. For if we are all moving together through this invisible tide, then none of us is truly separate. Your seconds and mine, your history and mine, your future and mine are all bound by the same unseen current. Time is not something you own. It is something we share. Have you ever lost time? A moment when you looked up at the clock and realized that hours had vanished like smoke, as if stolen. Or perhaps a childhood memory that should be there but isn't. A blank space where a page of your life should have been written. We dismiss these as tricks of the mind, gaps of attention, flaws in memory. But what if they are not accidents? What if time itself, true time, is incomplete? Physicists face a haunting problem. The universe does not add up. The galaxies spin too fast. The clusters of stars cling too tightly. The very expansion of the universe accelerates when it should not. What's missing? The answer they give us is dark matter. But perhaps that term is only half the story. Perhaps what is missing is not only matter, but time itself. Let us step carefully into this abyss. Dark matter, as invisible as breath, outweighs all the stars, planets, and dust we can see. It fills the cosmic web, unseen yet undeniable. But here is the unsettling question. Where did it come from? If time truly began in the Big Bang, if the universe burst from a singularity 13.8 billion years ago, then why did most of what it produced become invisible? Why would reality cloak itself in a shadow we cannot pierce? Unless dark matter is not matter at all. Unless it has lost time. Think of it this way. When light travels, it writes history. Every photon that reaches your eye carries a message from the past. A star's glow from 1,000 years ago. A galaxy's flame from 1 billion. Visible matter participates in this dance of time, carving past into present. But dark matter is silent. It neither shines nor scatters. What if it does not radiate because it does not belong fully to the present? What if it is residue, scraps of hours, fragments of moments that slipped through the cracks when the universe was born? In this sense, dark matter may be the archive of missing hours. Imagine the Big Bang as not only a birth of space, but a fracture of time, a great tearing where some pieces surged forward to create the reality you know, while others fell aside into shadow, gathering into an invisible ocean. You live in one river of time, but there may be others, darker, parallel, hidden, and dark matter may be the echo of those rivers, flowing alongside us, never touching, yet always pressing against the edges of our existence. Consider entropy, the great law that time should always move forward, that order collapses, that everything decays. Yet dark matter does not seem to decay. It does not burn, does not crumble, does not fade. It endures. Could this mean it is immune to time? Or worse, that it belongs to a different kind of time altogether? If so, then perhaps the reason we cannot detect it is because we are not aligned with its hours. We are trapped in our own, staring into a void of missing time we cannot comprehend. And here is the thought that makes even seasoned scientists grow quiet. What if consciousness itself occasionally slips into these missing hours? What if déjà vu, lost time, dreams that feel longer than the night, are not failures of the brain but glimpses into another stream of duration? Perhaps when you forget hours, they are not lost. They are elsewhere, written into the hidden pages of the universe's shadow book. And if that is true, then dark matter is not simply holding the universe together. It is holding the hours together. It is the scaffolding of chronology itself, the glue of history, the unseen chapters we cannot read, which means that your life may not be only the line you remember. It may have hidden margins, whole paragraphs of existence written in invisible ink. But here lies the most disquieting question of all. Who or what is reading that hidden book? If we cannot touch it, if we cannot see it, then who holds the missing hours of the universe? Is it nature alone? Or is there something, somewhere, keeping time in ways we cannot? The clocks we build are toys. The shadows we watch are signals. But the dark may be the true record keeper. And if that is so, then all of us are not just living in time. We are living in its absence too, breathing between hours, carrying the weight of all that was never written. Perhaps that explains why you sometimes feel haunted, not by ghosts of people, but by ghosts of moments, by seconds that slipped away, by time that should have been yours, but never was. Imagine this with me for a moment. Close your eyes, breathe, and let the vision rise. The universe not as a random scattering of galaxies, but as an intricate web stretched across billions of light years, woven of strands you cannot see yet, which bind everything into place. This is the cosmic web, and hidden within it lies the architecture of dark matter. The highways of dark matter do not shine. They are silent roads, invisible scaffolding, threads that never glow but whose presence we feel in the clustering of galaxies. Astronomers, when mapping the distribution of galaxies across the heavens, find not chaos, but structure. Galaxies are not scattered like sugar across a tabletop. They form filaments, vast rivers of starlight, separated by yawning voids. And what holds these rivers together, what allows them to stream in patterns too grand for chance, is dark matter. It is not just the galaxies that gather along these unseen highways, but the very shape of the cosmos itself. These filaments of dark matter guide galaxies as rivers guide boats, funneling them into clusters where their fates are tied together. And here's the haunting truth. Without dark matter, these highways would collapse, these galaxies would drift apart, and the universe would lose its elegance. Now, think about yourself in this analogy. What invisible threads bind you to the people in your life, to the moments you cherish? We are surrounded by unseen scaffolding too, not cosmic but emotional, psychological, spiritual, the love that holds families together, the memory that anchors a person to their past, the quiet bond between strangers who will never meet again, yet smile in passing on a crowded street. Isn't that in its own way a kind of dark matter, something invisible, something unmeasurable, yet profoundly real? Astronomers simulate these highways using supercomputers, feeding in equations of gravity, expansion, and particle physics. And when the simulations play out, they produce images of a web, filaments stretching like neural pathways in a brain, nodes glowing like synapses. And here's what takes the breath away. These cosmic maps look uncannily like networks inside our own minds. As above, so below, the human brain and the universe, both relying on invisible wiring to shape their very being. But where the brain's highways carry thoughts, memories, and sparks of electricity, the cosmic highways carry galaxies. Can you picture it? Entire galaxies, like lanterns adrift, flowing along the rivers of dark matter, merging, colliding, forming new stars. The highways don't just transport matter, they script destiny. If you could travel them, not with a ship, but with pure awareness, you might see the Milky Way itself sliding gently down a dark current on its way toward the Great Attractor, a gravitational basin where thousands of galaxies converge. And maybe you've felt this before, that tug towards something you can't see. That gravitational pull on your life that guides you towards certain places, certain people, certain lessons. Sometimes it feels like chance, but maybe, like dark matter, it is structure beneath the chaos. Maybe the universe is telling us something. Not everything guiding us has to be visible to be real. Scientists use gravitational lensing to map these highways. Imagine distant starlight bending, curving around the invisible scaffolding, revealing its presence through distortion. Like tracing the shape of a hidden object by watching how water flows around it. We cannot touch dark matter, we cannot see it, yet we know where it runs because light itself bows before it. And isn't that remarkable? Light, the very definition of visibility, bends to reveal the invisible. There is a lesson here for us as well. The visible often betrays the invisible. The way someone holds themselves can reveal a wound we cannot see. The light of their smile may bend around the gravity of grief. Just as astronomers trace the highways of dark matter through bent starlight, perhaps we too can trace the hidden forces in others through the way they move, the pauses in their voices, the unspoken weight in their eyes. The highways themselves are old, ancient, born from the earliest ripples in the cosmic microwave background, the leftover glow of the Big Bang. These ripples were like seeds, amplified by dark matter, growing into rivers and webs, and across billions of years, galaxies followed these invisible paths, like caravans on ancient trade routes. The dark matter highways are not just structure, they are history, time folded into patterns across space. If you could hover at the edge of the universe and look back, you would not see chaos, but something hauntingly orderly. Filaments, voids, clusters, nodes, all drawn out in an invisible ink. And here we are, the Milky Way itself clinging to one of these filaments, journeying on an unseen road we did not choose, carried by a gravity we cannot deny. So, I ask you gently, where are you on your own invisible highway? What unseen road has carried you here to this very moment, listening, reflecting, perhaps resting with these words as they flow into your evening? Do you feel the tug of forces you cannot name but which shape your destiny nonetheless? Just as galaxies are guided, perhaps we too are not entirely free-floating. Dark matter's highways remind us we are not drifting alone in chaos. We are part of a vast web, an interconnection deeper than sight. Galaxies flow along them, stars ignite upon them, and life itself emerges in their shelter. And though we may never see them directly, their presence is undeniable as the unseen bonds in your own life. So tonight, as you think of these highways, silent, invisible, eternal, perhaps you might also think of the unseen highways of your own existence, the bonds, the gravities, the patterns that carry you forward. And just as light bends to reveal the cosmic web, so may your own light, your kindness, your love, your curiosity, reveal the hidden highways in others. Because maybe the greatest truth of all is this: we live not in isolation, but on roads unseen, carried together toward a destination that none of us can yet see, but all of us are traveling toward. Picture the first galaxies of the universe, tiny flickers of light blooming in an ocean of darkness, like the first fireflies in a summer night sky. They did not emerge randomly. They were not accidents. They were born in cradles, pockets carved and deepened by dark matter, where gravity pooled, where the invisible highways bent space into hollows, gathering gas and dust, like a mother cupping her hands to hold water. These cradles, these halos of dark matter, were the first wombs of creation. They existed long before the galaxies themselves. In fact, without them, galaxies could never have formed. The hot plasma of the young universe would have drifted endlessly, spread too thin by expansion. But the halos of dark matter, massive, invisible spheres, pulled the gas inward, slowly, patiently, tenderly. They gave shape to formlessness. They gave boundaries to chaos. Think of this image: an unseen sphere, vast beyond comprehension, gathering hydrogen atoms that would one day ignite as stars. Without those invisible arms, gravity too weak to bind ordinary matter would have failed. Stars would not have clustered. Planets would never have formed. And you and I, we would never have been here. Dark matter is not just scaffolding, it is midwife. It birthed galaxies, then stood silently behind them, letting them shine, never demanding recognition. There is something profoundly human in that, isn't there? Have you ever thought about the people in your life who created the conditions for you to grow, but never stood in the spotlight? A parent who worked silently to give you safety, A teacher who believed in you when you did not yet believe in yourself. A friend who held you steady in a moment you might have fallen apart. They are like dark matter, shaping your world without needing to be seen. Astronomers today still trace the fingerprints of those first cradles. When they peer into the deep universe with telescopes like Hubble or the James Webb, they see galaxies from billions of years ago, some faint as whispers. These galaxies are nestled inside halos of dark matter, like children held in invisible arms. The light we see traveled for billions of years, yet even now the halos cradle them. The galaxies shine, but the dark matter does the holding. Let's reflect on the mechanics of this. Imagine an invisible bubble, 10, 100, even 1,000 times more massive than the visible galaxy it contains. The stars, the gas, the dust, everything we can see, floats inside this vast unseen sphere. The dark matter halo anchors them against the pull of expansion, against the tearing tides of cosmic drift. Like an unseen guardian, it whispers, "Stay close, hold together, shine," and so galaxies form. Stars ignite, planets dance, and within those planets life breathes. It is humbling, isn't it? To think that life itself, your heartbeat right now, is owed to an invisible architecture that held the universe steady long enough for complexity to bloom. But there is another side to this. Not every cradle was gentle. In some regions, the halos formed too close together. Galaxies collided, merged, were torn apart. Some never formed at all. Some were strangled before they could shine. The cosmic nursery was not only nurturing, it was also brutal. The same dark matter that birthed galaxies could also doom them, depending on circumstance. And isn't that also true of us? Our cradles, the environments we were born into, shaped us profoundly. Some of us were nurtured, held, loved. Some of us were tested, pressed, even broken. Yet here we are, galaxies in our own right, shining despite the conditions, or perhaps because of them. The halo does not guarantee what will form inside. It only creates the possibility. The rest is destiny, chance, will. Astronomers call these halos gravitational wells. Imagine a landscape drawn not on land, but in space itself. Valleys and ridges carved not by rivers, but by the invisible hand of dark matter. Gas rolls downhill into these valleys, gathering, compressing, kindling stars. If you could float above the early universe and look down, you would see it as a rippling terrain. Glowing filaments like mountain ranges, wells like basins, galaxies born in pockets, like seeds finding soil. And here's the astonishing part. These halos are still with us. Right now, the Milky Way is wrapped inside one. A halo of dark matter, perhaps 1,000,000 light years across. You and I, as we breathe, as we dream, are floating inside a dark matter cradle. It surrounds us on every side, unseen, silent, protective. We live inside an invisible womb, long after our birth. So let me ask you, does that change how you feel about the space around you? When you look at the night sky, can you imagine that every galaxy you see is not only itself, but also the unseen arms that hold it? And can you imagine your own life in the same way? That perhaps the most important structures holding you together are not the ones you can see, but the unseen ones. Perhaps you are in a cradle right now, a moment in life where invisible forces are shaping you. You might not recognize it until years later, when you look back and realize, that was the halo, the unseen presence that kept me from drifting apart. And maybe you are someone else's halo. Maybe without realizing it, you are the cradle that allows someone else to shine, the quiet presence holding them together as they form their own light. Just as galaxies owe their birth to halos they can never see, so too might someone's future self owe their birth to you. Dark matter's cradles remind us, creation is not just about what is visible. It is about the space that allows things to form, about the gravity that gives chaos a center, about the unseen scaffolding that allows beauty to bloom. When we speak of dark matter, we speak not only of mass and gravity, but of humility. For what greater humility exists than to shape the universe and remain invisible, to cradle galaxies and let them shine without ever demanding the credit? That is the poetry of dark matter, the quiet hand that gives without being seen. And tonight, as you drift with these thoughts, maybe you can rest in this truth. You are here because of cradles you will never see. Cosmic ones, yes, but also personal ones. Invisible kindnesses, invisible sacrifices, invisible structures of love. They are as real as any star, as necessary as any sun. So sleep easy, knowing this. You are held, not only by what you can see, but also by what you cannot. The universe has always been this way, and so have we. Close your eyes and imagine a stage unlike any other, not of wood, not of stone, but of curved space-time itself. A stage stretching wider than your imagination can hold, upon which galaxies whirl and collide like dancers in a slow cosmic ballet. The spotlight? Not visible light, not glowing stars, but the invisible scaffolding of dark matter, which sets the rhythm, draws the boundaries, and shapes the choreography of everything we see. For billions of years, galaxies have not been still. They move along the filaments of the cosmic web, drawn toward one another by unseen cords of gravity. And when their paths cross, they merge, collide, tear each other apart, or blend into something new. These are not rare events. They are the heartbeat of cosmic evolution. Our own Milky Way is locked in such a dance right now, slowly spiraling toward its neighbor, the Andromeda Galaxy. In 4 billion years, the two will meet, not in fire, not in a destructive crash, but in a vast, slow-motion waltz, lasting hundreds of millions of years. Their stars intermingling, their shapes reshaped, and yet, behind this grand performance, there is always a director, dark matter. The halos that cradle galaxies are the true partners in the dance. When galaxies collide, their visible stars and gas are only the costumes. The real mass, the true weight of the galaxies, lies in the dark matter halos that surround them. These halos determine whether the dance is graceful or violent, whether the galaxies merge seamlessly or shred each other into remnants. Let's consider an example. The Bullet Cluster, a collision of two galaxy clusters observed by astronomers. When scientists studied it, they found something extraordinary. The visible matter, the hot gas between the galaxies, was slowed down, disrupted, like smoke drifting in a gust of wind. But the dark matter, it passed through untouched, continuing its path as if the collision barely mattered. It was as though the stage remained steady, even as the dancers stumbled. The Bullet Cluster became one of the most compelling pieces of evidence for dark matter, showing us that it is not just invisible scaffolding, but a participant in the dance, moving to rules we cannot see. And now, let's bring this down to the level of our lives. Haven't you experienced collisions of your own? Encounters with others that changed you, sometimes gently, sometimes violently. Two people crossing paths, merging destinies, or passing by and leaving only ripples. The stars of our lives, our words, our actions, are visible. But the deeper forces, the unspoken, the emotional gravities, the unseen histories, we rarely acknowledge. Those are our dark matter halos. They decide how we respond when we collide. They determine whether we shatter, merge, or pass through unscathed. Astronomers run simulations of these galactic dances on supercomputers. They start with dark matter halos, then watch how galaxies orbit one another, pulled closer by gravity until they merge. What emerges is not chaos but elegance. Spiral arms stretch, twist, dissolve. Cores brighten as bursts of star formation ignite from the pressure of collision. Eventually, two galaxies become one, larger, steadier, reshaped. Isn't that the way of life as well? Collisions hurt, but they also create. They strip away old structures, but they ignite new stars. And the halos, the invisible, remain essential. Without dark matter, galaxies would not even meet. Expansion would carry them apart, drifting forever into cold emptiness. Dark matter ensures they dance, ensures they touch, ensures they merge. Without the invisible, there would be no connection. Think of this. The Milky Way and Andromeda's halos are already overlapping. Though the galaxies appear 2 million light-years apart, their dark matter is already entwined. They are bound together by a future collision that neither can escape. And in the same way, perhaps your own unseen halo is already overlapping with another's. Your destiny already entangled with people you have not yet met, with events you cannot yet imagine. Isn't it comforting, in some way, to think that your life is not drifting alone, but is already woven into a future tapestry? The stage of dark matter does not just host two dancers. Sometimes entire ensembles collide. Clusters of galaxies, hundreds, even thousands strong, smash together in colossal events. These collisions are the most energetic processes in the universe since the Big Bang itself. And again, dark matter quietly sets the choreography. The visible matter collides, heats, roils. The dark matter flows through, guiding the aftermath, shaping the final arrangement. From these collisions emerge new structures, larger galaxies, stronger clusters, tidal streams of stars flung into intergalactic space, like ribbons trailing a dancer's arm. Even black holes grow, merging into giants millions or billions of times the mass of the sun, all of it shaped by the invisible stage beneath. And here is a secret most don't know. Our own Milky Way is the product of many such collisions. We carry within us the remnants of smaller galaxies long since absorbed. When astronomers map the motions of stars in the Milky Way's halo, they see ghostly streams, rivers of stars that once belonged to other galaxies, now woven into ours. We are not singular. We are the product of countless dances, countless collisions, countless unions. And aren't we, as humans, the same? None of us are purely ourselves. We carry within us the imprints of others, their influence, their lessons, their love, their wounds. Every encounter leaves a mark. Every collision reshapes us. We are composites, mosaics, galaxies made of galaxies. So when you feel broken, or when you feel reshaped by an encounter too powerful to ignore, perhaps you can remember this truth. Even galaxies are broken and remade by collisions. Even stars are flung into strange orbits. And yet, from that breaking, beauty emerges. New stars ignite, new shapes are born. What feels like destruction may be the universe's way of sculpting something grander. Dark matter is the silent choreographer, setting the conditions for these encounters. It asks no recognition, yet it shapes the stage where galaxies meet. And maybe in our lives too, the unseen, our histories, our hidden longings, our subconscious gravities, are the true choreographers of our encounters. We think we are choosing. Perhaps we are dancing on a stage we did not build. But isn't that beautiful too? To know that even in our collisions, we are part of a grander dance, a choreography written across the stars. So tonight, as you let these thoughts settle, perhaps you might reflect on the collisions of your own life. Who have you merged with? Who have you passed by? What unseen halo carried you into contact? And can you trust that even in the chaos, there is a pattern, that the stage is steady, even when the dancers stumble? Because this is the truth the galaxies whisper. You are not drifting alone. You are dancing on a stage older than time, choreographed by forces you cannot see but which shape every step you take. Imagine stepping into a vast, endless cathedral, only to discover that most of it is empty, grand, echoing, hushed. That is what astronomers found when they mapped the large-scale structure of the universe. Between the glowing filaments of galaxies, the bustling nodes of clusters, lie the great cosmic voids, enormous expanses where almost nothing exists. And yet, even in these silent hollows, the unseen presence of dark matter whispers. The cosmic web is not evenly distributed. It is a network, yes, but like any web, it has gaps. Some stretches of the universe are crowded with galaxies, billions of them clustered like fireflies along invisible threads. Others, however, are desolate, lonely deserts spanning hundreds of millions of light years with barely a handful of galaxies inside. These are the voids, places where matter has fled, pulled outward by gravity into denser regions, leaving behind emptiness. But here's the riddle. Dark matter, too, is sparser in these voids. The invisible scaffolding retreats, its filaments bending around these hollows, leaving only faint wisps behind. And in this, we learn something profound. Even the invisible has shape. Even what we cannot see has contours, preferences, boundaries. If you could float in the middle of such a void, the universe would look strangely lopsided. In one direction, you would see distant galaxies, faint smudges glowing along the walls of the void. In another direction, almost nothing. A darkness so deep, it would feel less like space and more like absence. Astronomers say that standing in a void would feel like being in the hollow of a bubble, with galaxies only at the edges, like glitter on the surface of a sphere. And yet, this emptiness is not meaningless. It is part of the grand balance. For without voids, the dense filaments could not exist. Without emptiness, structure would have nowhere to grow. The web requires both, the crowded threads and the silent hollows. Creation is always a dialogue between fullness and emptiness. Pause with me here. Isn't that true of our lives as well? We too have voids, spaces of absence, times when something is missing, someone is gone. A silence fills what was once crowded, and yet those voids are not without purpose. They shape us. They give contrast to what remains. They define the boundaries of our personal web. Without those absences, the fullness would have no meaning. Without the quiet, the song would not be music. Astronomers discovered voids by tracing the distribution of galaxies in surveys. They expected randomness, but instead found patterns, walls, filaments, clusters, and between them, vast gaps. They built maps that look eerily like soap bubbles packed together, each void a bubble of emptiness, each wall a film of galaxies stretched between. It is humbling to realize that even nothingness can have structure, that absence itself can take form. Dark matter plays a central role in this. In the early universe, tiny fluctuations in density determined where matter would flow. Regions slightly denser attracted more matter, growing into filaments. Regions slightly emptier were drained, becoming voids. Dark matter amplified these contrasts, guiding the migration of galaxies into dense regions and deepening the hollows of emptiness. Without it, the structure would be smeared flat. Voids would not exist, and here we learn a paradox. Dark matter both builds and empties. It creates the filaments, but also the voids between them. It shapes the dense highways of galaxies, but also the deserts of nothingness. It is not only a creator of fullness, but a sculptor of absence. Think of your own life again. Isn't it the same with the unseen forces in you? The invisible histories that shape not only what you hold, but what you lack. The opportunities missed, the relationships never formed, the silences endured. Aren't those voids as much a part of you as the crowded, shining places? To be whole is to have both filaments and voids. Some of the largest voids in the universe are astonishing in scale. The Bhuta's void, for example, spans nearly 330 million light-years. To put that in perspective, if the Milky Way were at one edge, our galaxy would be a mere dot compared to the gulf of emptiness stretching before us. Within that vast space, only a few dozen galaxies have been found, when hundreds of thousands might have been expected. It is a cosmic desert, a reminder that the universe is not uniformly generous with its light. And yet, even the Bhuta's void is not truly empty. There are faint wisps of dark matter threading through it, tenuous filaments almost invisible, like strands of spider silk stretched thin. Even here, structure persists, subtle but real. The lesson is clear: nothing is ever truly nothing. Even in the most profound emptiness, something remains. I wonder if you felt this too. A moment in life when you thought you were standing in pure emptiness, only to discover later that faint threads remained. A friend who reached out when you thought you were alone. A memory that sustained you when all else seemed hollow. A whisper of connection, even in silence. The universe teaches us, even in voids, there are threads. Astronomers now study voids not only to understand absence, but also to probe the nature of dark energy, the mysterious force driving the universe's expansion. Voids expand faster than denser regions, their emptiness stretching with the acceleration of space. By studying how galaxies move around and within voids, scientists hope to uncover clues about this even deeper mystery. In this sense, the voids are laboratories, silent testbeds for the universe's secrets. And perhaps our own voids too are laboratories, places where, in silence, we discover truths we could not see in the noise of fullness. In absence, we hear echoes more clearly. In emptiness, we learn what cannot be taken from us. Maybe our voids are not mistakes, but invitations. Dark matter reminds us that the universe is not just about presence, but also about shape. Voids are shaped by what is missing as much as filaments are shaped by what is gathered. Together, they weave the balance of the cosmos. So, next time you look at the night sky and see the scattered stars, imagine not only the light you see, but the vast emptiness between them. Imagine the voids as real as the galaxies. And let that remind you, the spaces in your own life are not wasted. They are part of the design. The universe is a web of fullness and emptiness, of galaxies and voids, of filaments and hollows. Dark matter ensures both exist. And in that symmetry, we find beauty. Perhaps you can rest tonight knowing this. Your life too is not just the shining stars, but also the silent voids. Both matter. Both are necessary. Both are you. There are moments in the history of science when doubt is shattered. Not because someone's equations are elegant, or because a theory sounds beautiful, but because the universe itself delivers a piece of evidence so undeniable, so blunt that it feels almost like the cosmos saying, "Here, see for yourself." The bullet cluster is one of those moments. It is not merely a galaxy cluster. It is a cosmic scar, the frozen aftermath of a collision that ripped through the fabric of space on scales so immense our minds falter trying to picture it. And in its debris, scientists glimpsed one of the most direct, irrefutable proofs that dark matter is not just an idea, but something truly real. The bullet cluster, officially known as 1E065756. lies about 3.7 billion light-years away from Earth. What we see when we look at it is not a single galaxy cluster, but two clusters that have crashed into one another, like two immense rivers of galaxies colliding head-on at thousands of kilometers per second. Imagine cities colliding with cities, planets with planets, stars with stars, only magnified to a scale of tens of millions of light-years. The result is breathtaking. Galaxies scattered across space, clouds of superheated gas torn apart, shockwaves rippling through plasma hotter than the core of the sun. Astronomers call it the bullet because of the sharp, bow-shaped front of gas created as one cluster plowed through another. Now, why does this matter? Why does this strange galactic accident hold the key to dark matter? Because of what it reveals when we look not only with our eyes, but with the deeper tools of physics. When telescopes first examined the bullet cluster in visible light, they saw the galaxies themselves, islands of stars drifting largely undisturbed, like leaves floating on a river's surface. But when X-ray observatories like Chandra turned their gaze, they revealed something else: the glowing plasma of gas, the actual bulk of normal or baryonic matter. And here is the shocking twist. That gas, which should make up most of the visible matter in the cluster, was violently slowed down in the collision. Just as air resistance slows down a bullet, the plasma clouds of each cluster slammed into each other, heating to hundreds of millions of degrees, leaving behind the bow-shock shape we now see. If this were the whole story, if the only matter in the cluster were normal matter, then the center of gravity of this entire structure should lie where the plasma is. But that's not what the universe showed us using gravitational lensing, the bending of light from background galaxies as it passes near massive objects. Astronomers mapped the true distribution of mass. In the bullet cluster, what they found was astonishing. The gravitational weight of the cluster was not aligned with the slowed down plasma, but with the galaxies, which had largely passed through the collision unaffected. This meant that most of the mass of the cluster was invisible, non-collisional, and spread where the galaxies were, not where the plasma, the bulk of the visible matter, had been left behind. This was no small discrepancy. The dark matter's gravitational influence was so strong that it overshadowed the contribution of normal matter entirely. It was like peeling away a mask. The plasma, the gas, the visible content of the universe, those are not the dominant players in the dance. The real body of the cluster, its massive, unseen skeleton, is dark matter, and the bullet cluster laid it bare for all to see. To appreciate why this moment was so profound, you have to understand the context. Before the bullet cluster, the evidence for dark matter was largely indirect. The flat rotation curves of galaxies, the gravitational lensing of galaxy clusters, the formation of large-scale structures, all of these hinted loudly at the presence of some unseen mass. But skeptics always had an escape route. They argued that perhaps our understanding of gravity itself was incomplete. Perhaps Newton and Einstein, for all their brilliance, had left something missing in their equations. Modified Newtonian dynamics, M-on-D, TVES, and other attempts at rewriting the laws of gravity were proposed as alternatives. Maybe the universe didn't need unseen matter. Maybe it just needed new physics of force. But then came the bullet cluster, and suddenly those arguments began to collapse. Why? Because if it were just gravity that was wrong, then the gravitational mass should still line up with the visible matter, the gas clouds, since those are what make up most of the baryonic material in clusters. The bullet cluster showed otherwise. The gravity was clearly separated from the bulk of visible matter. Something massive and invisible that did not interact like normal matter had passed through the collision, dragging galaxies along with it, while the plasma was left behind. This was not a failure of gravity. This was evidence of something new, something dark. Even the skeptics struggled. It is one thing to tweak equations to explain the rotation of galaxies. It is quite another to explain a split, gravity in one place, visible matter in another. The bullet cluster, along with subsequent examples like the train wreck cluster, Abel 520, created a gallery of cosmic collisions where dark matter's fingerprints were written in the sky. And yet, even in this clarity, mysteries remained. For one, we could not see the dark matter itself. We could only infer it from its gravity, like a phantom leaving footprints in the sand. The bullet cluster was proof, yes, but it was proof of an absence, a ghostly mass, elusive, silent, unlit. Scientists asked, what is it made of? Could it be some new particle beyond the standard model? WIMPs, axions, sterile neutrinos? Could it be something even stranger? A property of space-time we cannot yet imagine? This is where the beauty of the bullet cluster truly lies. It is not simply a smoking gun. It is also a doorway. It forces us to accept that dark matter is not just a fudge factor, not just a mathematical trick. It is something real, out there, shaping the universe in silence. And the collision gave us a glimpse not only of its existence, but also of its nature. Unlike normal matter, it does not heat up, radiate, or collide. It passes through itself almost as though it were made of shadows. That ghost-like behavior is the very reason it has sculpted the cosmos into the web-like structures we see today. Pause for a moment and let yourself feel the gravity of this. We are talking about entire galaxies smashing together at unimaginable speeds, leaving scars of light and plasma across the void. And yet, the deepest story told in that chaos is about something we cannot see, something more massive, more dominant than everything luminous combined. In the bullet cluster, the cosmos pulled back the curtain and whispered, "You have been looking at the wrong actors. The real stage belongs to the unseen." And now, I want to ask you, how does this make you feel? Knowing that even in the violence of colliding galaxies, there exists a deeper, invisible truth. Does it make you feel small, fragile, like a child listening to the infinite? Or does it make you feel empowered, knowing that the universe, in its quiet generosity, leaves us clues so bold, so undeniable, that we can trace the unseen by its fingerprints? As you sit with this thought, whether you are curled up in bed, letting this narration flow into sleep, or listening with wide eyes on a walk beneath the stars, ask yourself, what else lies hidden in plain sight, waiting for a collision, a disruption to reveal itself? Because the bullet cluster is not just about dark matter. It is about a truth we can carry into our own lives. Sometimes what we see on the surface is not the whole story. Sometimes the real weight lies elsewhere, invisible, but no less real. And so, as scientists trace lensing arcs and galaxies scattered like embers, as they study collisions written in the ink of the cosmos, they are not just mapping dark matter. They are reminding us that the universe holds secrets that can only be uncovered when we look with new eyes. When we dare to believe that what we cannot see might still exist, might even dominate the story. That is the legacy of the bullet cluster. A cosmic accident turned into a revelation, a violent collision that became one of the most serene truths we now know. That dark matter is real, it is vast, and it shapes the stage upon which all of creation performs. When we talk about evidence for dark matter, we often imagine dramatic cosmic events, the crash of galaxy clusters, the swirling dance of spiral arms defying gravity, or the rippling relic radiation left over from the birth of time itself. Yet sometimes the proof is quieter, subtler, more delicate. Sometimes the universe whispers rather than shouts. And nowhere is this whisper more hauntingly clear than in weak gravitational lensing, the gentle bending of light by unseen mass. This is not the dazzling spectacle of strong lensing, where massive galaxies warp the light from more distant objects into bright arcs, rings and mirrored doubles across the night sky. Weak lensing is far more fragile, like the faint trace of a breeze across still water. It takes billions of galaxies, billions of points of starlight to reveal the pattern, and yet, through it, we glimpse the fingerprints of dark matter spread across the cosmos, forming a shadow map of the unseen. Imagine this: light, the purest messenger of the cosmos, traveling unbroken for billions of years. A photon leaves the surface of a distant galaxy, carrying with it the memory of where it came from. It crosses oceans of time, vast voids, tangled filaments of galaxies, until it reaches us. But along the way, its path is not straight. Every massive object it passes by, every cluster, every dark halo, every web of unseen matter tugs at it with gravity, bending its route ever so slightly. By the time that photon arrives in our telescope, the galaxy it came from no longer appears as it truly is. Its shape is stretched, its light is twisted, its orientation skewed by invisible hands. To the naked eye, these distortions are imperceptible. A single galaxy looks normal, perhaps a little oval, perhaps slightly askew. But when astronomers gather millions of galaxies, when they look not at the individual but at the collective, a pattern emerges. It is as if the universe itself is speaking through statistics, showing us that these subtle shears and stretches are not random. They are the mark of hidden mass. This is weak lensing. Not dramatic arcs, not blazing rings of light, but the quiet chorus of countless galaxies whispering, "We have been bent by something you cannot see." One of the most profound applications of weak lensing has been in mapping the cosmic web. Using deep surveys like the Canada-France-Hawaii Telescope Lensing Survey, CFHTLens, the Dark Energy Survey, DS, and later the Hyper-Suprime Cam Survey in Japan, astronomers have stitched together maps of the invisible scaffolding of the universe. What emerges is breathtaking. Filaments of dark matter stretching across cosmic voids, connecting galaxy clusters like the sinews of a great, invisible body. These maps look eerily organic, like neurons in the brain or rivers spreading through a delta. The hidden structure beneath everything luminous is suddenly revealed. And here's the astonishing part. The weak lensing maps match what our cosmological simulations have long predicted. The standard LCDM model, cold dark matter with a cosmological constant, has always suggested that galaxies and clusters form within dark matter halos, connected by filaments of unseen substance. Weak lensing observations confirm it. The distribution of dark matter aligns with the patterns of light, just as theory foretold. The universe once again nods back at us. Yes, you are on the right path. But weak lensing does more than just confirm dark matter's presence. It allows us to weigh it, to trace its evolution through cosmic time, to test whether its behavior matches our expectations. For instance, lensing has shown us that dark matter is not smooth, but clumpy, forming halos and subhalos that nest like Russian dolls. It tells us that the universe is dominated not by stars, not by gas, not even by galaxies, but by this invisible substance that bends light yet emits none of its own. There is also a beauty in how weak lensing demands patience, humility, and care. Unlike the bullet cluster's dramatic split of matter and mass, weak lensing is statistical, requiring years of surveys, enormous collaborations, and meticulous removal of bias. Every atmospheric blur, every telescope misalignment, every imperfection in a CCD detector could masquerade as a lensing signal. Astronomers must peel away these layers like careful restorers working on an ancient painting, until finally the hidden image beneath is revealed. It is science at its most delicate and its most profound. Pause for a moment and think about this. Billions of galaxies, each one an island of stars, scattered across the universe. To us, they are pinpricks of light. To lensing, they are brushstrokes in a greater portrait. When their shapes align statistically in ways they should not, when their faint elongations echo one another across the sky, they are telling us about the invisible hands tugging on their light. It is as though the galaxies are conspirators in a cosmic secret, and lensing is the language through which they whisper it. And I want to turn this back to you, listening right now. Doesn't this make you wonder about the unseen influences in your own life? Just as galaxies are subtly bent by invisible forces, aren't we too shaped by things we cannot see? Memories, emotions, histories, currents of time and chance. Weak lensing is a cosmic metaphor, a reminder that what seems random, what seems unexplainable, may in fact be the quiet pattern of something larger, something hidden but real. Scientists now dream of future surveys that will take weak lensing to unprecedented depths. The Vera Rubin Observatory's Legacy Survey of Space and Time, LSST, will image billions of galaxies, offering the most detailed weak lensing maps ever made. Euclid, launched by the European Space Agency, and NASA's Nancy Grace Roman Space Telescope will push even further, probing both dark matter and dark energy through the bending of light. These missions are not just instruments, they are eyes for humanity, gazing deeper into the whispering shadows of the cosmos. And what will we find? Will weak lensing continue to confirm our models, tightening the case for cold dark matter? Or will it show cracks, small deviations hinting at new physics, perhaps warm dark matter, self-interacting particles, or something stranger still? That is the thrill of this field. We already know enough to say with certainty. Something unseen is there, tugging on light, sculpting galaxies, threading the web of creation. And yet, every photon bent, every galaxy stretched, may carry within it the seed of a deeper mystery, a clue that could one day shatter what we think we know. So next time you look at the night sky, at those fragile dots scattered in blackness, remember their shapes. Their alignments, their very images, may have been bent by invisible structures that outweigh everything luminous combined. The stars we see are only half the story. The rest is hidden in shadows, but shadows that leave fingerprints, shadows that we can now trace with patience and wonder. This is weak lensing, the universe's faint whisper, the subtle fingerprint of the invisible, the quiet chorus of galaxies, revealing the truth of dark matter. There is something almost poetic about the idea that the universe has a skeleton, not a skeleton of bone and marrow, but one of invisible threads, dark matter filaments stretching across billions of light years, binding galaxies into vast clusters, weaving voids into their hollow depths. And though we cannot see this skeleton directly, we can trace its outline in the most delicate of ways. Through cosmic shear, the large-scale imprint of weak gravitational lensing. Cosmic shear is one of those terms that sounds technical at first, almost sterile, but when you peel back the layers, it becomes deeply human, because it is, in essence, about reading the universe's handwriting. Imagine billions of galaxies scattered across the night sky like grains of sand. Each one emits light, and each one's image is subtly stretched, distorted, or skewed as that light journeys through the gravitational landscape carved by dark matter. Individually, these distortions mean nothing, but taken together, across the entire canvas of the sky, they form a collective pattern, a shear, that tells us about the invisible scaffolding holding the cosmos together. This shear is not dramatic, not something you can spot with the naked eye. It is faint, statistical, almost ghostly, but through careful observation, through vast surveys that track the shapes of millions upon millions of galaxies, scientists can reconstruct maps of dark matter itself. These maps are among the most beautiful achievements of modern astronomy. They reveal the cosmos not as an empty stage with bright actors, but as a woven tapestry, where luminous galaxies are mere beads threaded along the great invisible strings of matter. The first hints of cosmic shear were detected in the late 1990s, and at first they seemed almost too delicate to trust. Astronomers needed extraordinary precision to tease out this signal from noise, atmospheric turbulence, instrumental imperfections. Even the slight asymmetries in telescope mirrors could mimic the effect. But as technology improved, as detectors grew sharper and statistical methods more sophisticated, the signal emerged more confidently. By the mid-2000s, large surveys like the Canada-France-Hawaii Telescope Lensing Survey, CFH-TLENS, began producing full-sky maps that revealed the dark matter distribution across hundreds of millions of light years. What they showed was stunning confirmation of theory. The LCDM model of cosmology, L for the cosmological constant, representing dark energy, and CDM for cold dark matter, predicted that structure in the universe should grow hierarchically. Tiny ripples in the primordial plasma after the Big Bang would, under the pull of gravity, grow into filaments, clusters, and superclusters, with dark matter forming the skeleton around which visible galaxies condensed. Cosmic shear surveys confirmed this with almost eerie fidelity. The maps matched simulations with remarkable accuracy. The filaments were there, the knots were there, the voids were there. The invisible skeleton was real. But cosmic shear does more than simply confirm what we already suspected. It is also one of our sharpest tools for testing the universe's evolution. Because the distortions of light come from everything between us and the galaxies being observed, cosmic shear encodes a history of structure growth. By studying galaxies at different distances and therefore different times in the universe's past, astronomers can piece together how dark matter clumps have grown over billions of years. And this in turn tells us about two of the greatest mysteries in physics: the nature of dark matter and the strange repulsive force of dark energy that accelerates the expansion of the cosmos. Here lies the quiet tension. In some surveys, the growth of structure inferred from cosmic shear appears slightly slower than what the LCDM model predicts, based on measurements of the cosmic microwave background, CMB. It's a subtle discrepancy, but in cosmology, subtle discrepancies can be the cracks that one day break open new physics. Are we misinterpreting the data? Are systematic errors still lurking in our analyses? Or could this be a sign that something fundamental about dark matter, about dark energy, or even about gravity itself is not quite what we think? Think of it. Billions of galaxies, faint smudges of light, telling us that perhaps our picture of the universe is incomplete. That the invisible skeleton is real, yes, but its growth may be whispering of forces we do not yet understand. And here is where the future excites me most. Cosmic shear is still in its infancy compared to what is coming. The Vera C. Rubin Observatory, with its legacy survey of space and time, LSST, will observe the southern sky in unprecedented detail, capturing the shapes of billions of galaxies over a decade. ESA's Euclid mission, already gazing into the cosmos, is designed specifically to measure weak lensing and cosmic shear across a third of the sky. NASA's Nancy Grace Roman Space Telescope, with its wide-field infrared vision, will join the effort later in the decade. Together, these missions will turn cosmic shear from a subtle signal into a roaring chorus, mapping the universe's dark skeleton with unparalleled clarity. It is humbling to think about. For most of human history, the night sky was a dome of stars, mysterious and eternal. Then we learned those stars were suns, those suns grouped into galaxies, those galaxies scattered across space. And now, in our time, we are learning that all of those luminous wonders ride on an invisible skeleton. We are no longer just stargazers. We are cartographers of the unseen. But I want you to pause, here and now, and think about what this means personally. Cosmic shear is not just about science, it is about perspective. It reminds us that there are structures, forces, frameworks in our lives that we may not see directly, but that shape us nonetheless. The way memories anchor us, the way culture and history guide us, the way invisible connections link us to one another. Just as galaxies trace the filaments of dark matter, we too trace invisible filaments, threads of meaning, love, and loss that bind us into a human web. And here's a question I want you to hold in your heart. If the universe has a skeleton we cannot see, what about you? What invisible framework carries your story, your choices, your becoming? What filaments of influence, hidden yet real, guide the way your light bends? This is what cosmic shear teaches us. The most profound truths are not always loud. They are not always dramatic arcs or crashing clusters. Sometimes they are whispers written across billions of galaxies, waiting for those patient enough to listen. Sometimes they are invisible threads weaving everything luminous into a greater whole. And maybe, just maybe, if we learn to listen to those whispers in the cosmos, we can also learn to hear them in ourselves. That is the gift of cosmic shear, the quiet unveiling of the universe's skeleton, the soft but undeniable proof that even the unseen can be mapped, traced, and understood. The bullet cluster is often hailed as the smoking gun of dark matter. Its dramatic separation of hot gas and gravitational mass shocked the scientific community and silenced many skeptics. But here is the thing about the universe. It rarely gives us only one clue. The cosmos is generous, scattering breadcrumbs across the void, whispering truths through multiple examples, not just one. And so, beyond the bullet cluster, we find a growing gallery of colliding galaxy clusters. Each one a cosmic experiment that reinforces, complicates, and deepens our understanding of dark matter. Let us journey into these collisions, these titanic cosmic wrecks, where galaxies glide like ghosts, gas clouds crash like storms, and dark matter slips silently through the chaos, leaving behind only the bending of light as its trail. One of the most fascinating of these is Abell 520, sometimes called the train wreck cluster. Located about 2.4 billion light-years away, Abell 520 defied expectations when astronomers first observed it in detail. Unlike the bullet cluster, where dark matter aligned with galaxies and left the gas behind, Abell 520 seemed to show a strange central clump of dark matter with very few galaxies embedded in it. Imagine expecting the galaxies to ride alongside the dark matter like boats carried by a tide. Yet here, the tide appeared to pool in the center while the boats drifted elsewhere. This anomaly sparked debate. Was Abell 520 an exception to the rule, an oddball collision that revealed some previously unknown property of dark matter? Or was it a trick of observational uncertainty, a misinterpretation of messy data? Over time, as new observations refined our maps, the central clump remained, but interpretations diverged. Some suggested it could be a sign that dark matter might interact with itself in ways we hadn't anticipated, perhaps colliding and sticking faintly during these cosmic impacts. Others argued it could still be explained within the framework of cold dark matter, If only we understood the details of the cluster's complex history. What Able 520 shows us is that even when dark matter reveals itself clearly, it does not always do so in ways we expect. It is as though the universe is saying, yes, I will show you the invisible, but do not think you can reduce me to a single example, a single neat model. The truth is often more complex, more layered. Another striking case is Max J0025.4 2022, sometimes referred to as the baby bullet. Like its more famous cousin, this system also shows a collision between two clusters, with the same dramatic separation between normal matter and dark matter. In fact, its resemblance to the bullet cluster strengthened confidence that what we saw there was not an accident or coincidence. These two cosmic crashes, far apart in both distance and time, told the same story. Galaxies and dark matter pass through one another like ghosts, while normal matter, the hot plasma, collides and lingers behind. When two independent witnesses give the same testimony, our confidence in the truth grows. That is what the bullet cluster and the baby bullet gave us, corroboration, a cosmic echo confirming the whisper of the unseen. And then there is El Gordo, Spanish for the fat one, the most massive galaxy cluster merger known, lying about 7 billion light-years away. El Gordo is colossal, so massive it makes even the bullet cluster look small by comparison. When scientists mapped its structure, they found the same familiar story. Galaxies and dark matter streamed ahead, while the plasma gas was left behind. Lighting up in X-rays, El Gordo is important, not just because of its scale, but because of its time. At 7 billion light-years away, we are seeing it as it was when the universe was only about half its current age. For something so massive to exist, so early challenges our understanding of how structures formed. It suggests that dark matter's role in building the cosmic web was even more profound than we thought. Without it, the universe simply could not have assembled such a behemoth so quickly. Each of these clusters is like a verse in a larger song. The bullet cluster sang the first loud note clear and sharp. Able 520 added dissonance, a reminder that the tune is complex and layered. The baby bullet harmonized, repeating the melody in a different key. El Gordo roared a deep bass line, ancient and thunderous. Together, they create a chorus that tells us dark matter is not speculation. It is reality, shaping the grandest structures in the cosmos. And yet, notice the tension. Some clusters line up perfectly with our expectations of cold dark matter, silent, collisionless, invisible. Others, like Able 520, tease us with anomalies that hint at something more complex. Could dark matter sometimes interact with itself ever so faintly, leaving behind subtle signatures in cluster collisions? Could there be different flavors of dark matter? Some perfectly invisible, others whispering through rare interactions? Or are we simply seeing the limits of our instruments misled by cosmic coincidences? This is where science thrives, in the space between certainty and doubt. The bullet cluster gave us proof. The others gave us nuance, and together they form a living debate, one that continues to evolve with each new observation. Now, let me turn this back to you, the listener. Imagine these collisions not just as abstract astrophysical events, but as metaphors. Massive structures colliding, galaxies drifting through one another unscathed, while the densest, most obvious material, the hot gas, slams together and slows down. Doesn't it remind you of how, in life, sometimes the visible conflicts, the loud crashes, are not the deepest forces at play? Sometimes what passes quietly, what remains unseen, holds the real weight, the real influence. And doesn't it also remind you that truth rarely comes in a single story? Just as the bullet cluster alone might have misled us into thinking dark matter always behaves simply, Able 520 shows us that reality is richer, more intricate. The universe resists being flattened into a single narrative. It demands that we listen to all its verses. So the next time you hear someone ask, "But is dark matter real?" think of this gallery of collisions. Think of the bullet cluster, the baby bullet, El Gordo, Able 520. Each one a scar in the cosmos, a cosmic accident frozen in time. Each one revealing the hand of the unseen, whether in clarity or complexity. Together, they make the case undeniable. Whatever it is, however it works, dark matter is out there, shaping the stage of creation. And maybe, just maybe, in listening to these cosmic collisions, we can learn something about our own collisions, about how the visible clashes in life are not always the deepest truths, and how the invisible frameworks we carry silently are often the ones that truly shape us. Imagine standing in a vast, dark forest at midnight. The trees are hidden, the undergrowth cloaked in shadow. You cannot see the creatures that move within it, yet you know they are there, not because you catch them with your eyes, but because you hear the snapping of twigs, the rustle of leaves, the distant cry of an unseen bird. This is how physicists try to sense dark matter. They do not see it directly. Instead, they listen for the echoes, the aftershocks, the strange murmurs in the universe that hint at its presence. These echoes come in the form of gamma rays, neutrinos, and other cosmic messengers. Tiny signals from deep space, woven into the cosmic noise. To understand why these signals matter, let's take a step back. Dark matter is elusive. It does not shine, reflect, or absorb light. It floats through galaxies like a ghost. So, how do we hope to detect it? One strategy is to consider what happens if dark matter particles collide, annihilate, or decay. When two dark matter particles interact, they may release energy in the form of particles we can detect: gamma rays, neutrinos, or even exotic cosmic rays. In other words, though dark matter is dark, it may leave behind fingerprints of light, whispers of energy that betray its shadowy presence. Take gamma rays, for instance. These are the most energetic form of light, far beyond ultraviolet or X-rays. They are born in cataclysmic processes, exploding stars, black hole jets, or radioactive decay. Yet, physicists suspect they may also be born from dark matter. If two dark matter particles annihilate, one possible outcome is a flash of gamma radiation. These flashes, if they occur, would not scatter randomly. They would concentrate in places where dark matter itself is densest, like the center of our galaxy, or in nearby dwarf galaxies orbiting the Milky Way. And so, astronomers turn their telescopes not just toward bright stars, but toward dark places. Instruments like NASA's Fermi Gamma Ray Space Telescope have been peering at the sky for over a decade, collecting streams of high-energy photons. When scientists mapped the gamma ray sky, they found something curious: a mysterious glow at the center of our Milky Way. This galactic center excess, as it is called, is brighter than what known astrophysical sources alone can explain. Some propose it is the roar of unseen pulsars. Others whisper that it may be the annihilation of dark matter, painting the heart of our galaxy in invisible fire. Yet, gamma rays are not the only trail. There are also neutrinos, those ghost-like particles that stream through your body by the trillions every second without you ever noticing. Neutrinos are elusive, almost impossible to trap, but physicists have learned to catch a few. Buried deep under ice in Antarctica is a telescope unlike any other, IceCube. It does not look up at the stars, but down into the Earth itself, waiting for neutrinos that pass through the planet and leave tiny flashes of blue light in the ice. If dark matter particles annihilate, they could release neutrinos, which would then travel unhindered across space and arrive at detectors like IceCube. For years, researchers have combed the data asking, is there an excess of neutrinos from the galactic center? From the sun, perhaps, where dark matter might accumulate and collide in its fiery heart? The evidence so far remains tentative, a puzzle with missing pieces, but each new year of observation sharpens the picture. And then there are cosmic rays, high-energy particles, mostly protons and electrons, that streak across space like messengers of distant violence. Some theories suggest dark matter could produce unusual cosmic ray signatures, an excess of antimatter, for example, such as positrons or antiprotons. Experiments like AMS-02, mounted on the International Space Station, sift through these particles, measuring their energies and compositions. Intriguingly, AMS-02 did detect an excess of positrons, more than standard astrophysical models predict. Could dark matter be behind this? Or is it simply pulsars once again, flooding the cosmos with antimatter streams? The debate continues, sharp and unresolved. What's beautiful about these indirect searches is their unity. Gamma rays, neutrinos, cosmic rays. Different messengers, traveling across different channels of physics, all potentially pointing to the same hidden truth. It's as if dark matter is a fugitive, leaving behind faint traces at multiple crime scenes. Each type of evidence alone may be ambiguous, but taken together, they begin to sketch an outline. A glow in the gamma ray sky, a whisper in the neutrino flux, an unexpected surge in antimatter. Could it all be coincidence, or is it the cosmos gently, patiently trying to tell us something? Still, caution is necessary. Astrophysics is notoriously messy. Pulsars, supernovae, black holes, all of these can mimic the signals dark matter might leave. The challenge, then, is disentangling the music of the universe from the noise. Scientists create models, compare predictions, test them against observations, refine, discard, try again. The process is slow, sometimes frustrating, but filled with a kind of quiet poetry. We are searching for what we cannot see, using what little we can. But perhaps what is most striking is the philosophy behind it. Even when the signals are ambiguous, even when the data resists interpretation, humanity persists in listening. We point our telescopes, bury detectors deep in ice and rock, launch instruments into orbit, all to chase shadows. It is a reminder of how deeply we yearn to understand, how much we are willing to invest in seeking truth, even when it hides from us. So, the next time you look up at the night sky and imagine its silence, know that it is not silent at all. It hums with gamma rays, it shivers with neutrinos, it pulses with cosmic rays. And hidden within this celestial music may be the faint chords of dark matter itself. Perhaps one day, when our instruments sharpen and our understanding deepens, we will finally hear the melody clearly. Until then, we keep listening, patient and persistent, like children pressing their ear against the heart of the universe. Close your eyes for a moment and imagine this: a great hall beneath the earth, deeper than the roots of any tree, where silence reigns. No footsteps, no birdsong, not even the hum of machines, only the faint breath of the world pressing down from above. In this place, shielded from cosmic noise, humanity waits with instruments more sensitive than anything your ancestors could have dreamt of. They wait for whispers of a hidden universe, for the brush of a particle no one has yet caught. This is where the future of dark matter detection is born. We stand today at the edge of possibility. The experiments that hunt dark matter already operate with unimaginable precision, but the truth is, we may only just be scratching the surface. Every year, scientists build detectors that are larger, colder, and quieter than the last, each one reaching further into the shadows, hoping to grasp what has slipped through our fingers for nearly a century. And the question that hovers like a star in the distance is this: will we finally see the unseen? Let's begin with direct detection. You've heard already of xenon tanks, noble liquid detectors glowing faintly in underground caverns. The next generation is not just tanks, it is oceans. The Xenont experiment in Italy and the Luke Zeppelin LZ experiment in South Dakota are already in operation, pushing sensitivity to levels that would have been science fiction just decades ago. But beyond them, designs are emerging for Darwin, a detector so massive it would contain dozens of tons of liquid xenon, like a cathedral of invisible light. Imagine a particle of dark matter gliding silently through space, through the walls of our world, and into this immense chamber. For the briefest instant, it collides with an atom, releasing a flicker of light. That flicker, tiny, fragile, yet unmistakable, would be enough to change everything. But what if dark matter does not behave the way we expect? What if it is lighter, slipperier, subtler than our models predict? Then the dream shifts. Scientists imagine detectors made not of xenon, but of superconductors so delicate they quiver when a particle as light as a few MeV touches them. Others design devices from graphene sheets, so thin and sharp they can feel a single electron being nudged out of place. Some propose crystals cooled nearly to absolute zero, where even the faintest energy deposition becomes visible, like frost catching a spark. The future of detection is not one path. It is a forest of experiments, each one chasing a different possibility, each one a prayer to the cosmos. Show yourself. And then there is the frontier of indirect detection. Our satellites are already watching the skies: Fermi, AMS Neo 2, IceCube. But the instruments being imagined for tomorrow are grander still. Think of the Cherenkov Telescope Array, CTA. An army of telescopes spread across deserts, each one built to capture gamma rays from the heavens with unprecedented clarity. If dark matter annihilates in the galactic center, CTA may be the eye that finally sees its glow clearly, cutting through the confusion of pulsars and supernovae. Or consider next-generation neutrino detectors like Hyper Kamiokande in Japan. Vast tanks of water so pure that they sparkle when even a single neutrino brushes past. These observatories may one day hear the faint hymn of dark matter from the sun, or from the silent gulfs of intergalactic space. And yet, even these efforts may not suffice. Some dream bigger still, beyond Earth, beyond orbit. Imagine a fleet of satellites, each watching a different patch of sky, connected by a web of data that stretches across the solar system. Imagine observatories on the moon, shielded from Earth's noise, where instruments can stare into the cosmos with unblinking patience. Imagine detectors buried in the ice of Europa, or floating in the silence of interstellar space, beyond the sun's influence, waiting for a whisper from the deep. It sounds like science fiction, but so did the idea of building telescopes the size of football fields in the desert, or lowering tanks of xenon into the Earth. There is also the path of particle accelerators, where instead of waiting for dark matter to come to us, we go to it. The Large Hadron Collider has not yet found dark matter, but the future brings new machines. The Future Circular Collider, FCC, in Europe, and the International Linear Collider, ILC, in Japan. These machines could smash particles together at energies far greater than anything yet achieved, possibly creating dark matter directly. Picture this. For a fleeting instant, in the fire of a collision, a dark matter particle is born. It slips away unseen, but its absence is felt, like a missing coin from a perfectly balanced scale. That absence could be the proof we've long awaited. But perhaps the most profound future path is not in machines or detectors, but in ideas. For every experiment that rises, there are countless theorists working quietly at chalkboards and computers, asking, what if dark matter is not one particle, but many? What if it interacts through a hidden force, a dark photon, invisible to us, but binding its particles into structures we cannot yet imagine? What if dark matter is not cold, but warm or fuzzy, or tangled in a quantum field that blurs across galaxies? Each hypothesis inspires a new design, a new experiment, a new way of listening. The hunt is not just technological, it is imaginative, creative, deeply human. And as we look forward, one question hums louder than all the rest. What happens when we finally succeed? What happens when the first clear, undeniable signal of dark matter is seen? Whether in a detector's flash, a telescope's glow, or a collider's missing energy, it will not only confirm what we have long suspected, it will open a door. It will force us to rewrite the textbooks of physics, to reconsider the story of the cosmos. It will be like discovering that Earth was not the center of the universe, or that atoms are not indivisible. It will remind us once again that reality is stranger, deeper, more intricate than we thought. The search for dark matter is more than science. It is a testament to patience. Decades of failure have not dimmed the quest. Generations of physicists have dedicated their lives to instruments that may never detect a single event, trusting that persistence will one day be rewarded. In a sense, the very act of searching is itself a kind of beauty. It shows us who we are, creatures willing to build cathedrals in the dark, to wait for whispers from the cosmos, to pursue truth even when it hides. So as topic 2 draws to a close, I invite you to reflect. Somewhere, in the silence of deep underground chambers, in the cold vacuum of space, in the hum of a collider, the answer may already be waiting. Perhaps it is drifting through you this very moment, unnoticed, unmeasured, a dark particle from the birth of the universe itself. The future of detection is the future of listening. And if we listen carefully enough, with love, with patience, with imagination, we may finally hear the universe tell us its deepest secret. And so, dear listener, we arrive at the quiet end of tonight's journey. We began by asking simple, impossible questions. What lies hidden in the shadows of the universe? What forces cradle galaxies, hold them together, and sculpt the cosmic web like invisible hands weaving a tapestry? We walked step by step, topic by topic, into the heart of dark matter, not through sight, but through faith in science, through whispers of particles, through hints in starlight, gamma rays, neutrinos, cosmic rays, and the silence of underground chambers where detectors wait like monks in meditation. If you've stayed with me this far, if you've allowed yourself to rest within these words for over 2 long hours, know this: you are part of the search too. For each time you close your eyes and wonder about the stars, for each time you let yourself feel awe, you keep this flame alive, the flame of curiosity, of mystery, of patience. And isn't that what it means to be human? To live within questions, to love the unknown enough to follow it, even when the answers remain far away. I want you to know how deeply grateful I am for your time, for your presence, for your listening heart. It is not easy in this world of noise and distraction to give yourself over to something quiet, slow and reflective. Yet here you are, still listening. Like dark matter itself, invisible yet essential. Your listening presence is the force that holds this channel together. You are the reason these words take shape, the reason these journeys are worth walking. So let me ask you, where are you listening from tonight? From a quiet room, the lights dimmed, drifting towards sleep. From the chaos of a city, headphones on, carving out a small sanctuary for yourself. Or perhaps from somewhere between, half awake, half dreaming, letting the rhythm of words carry you like a river. However you are here, you belong. However you feel, you are seen. And if tonight's voyage left you with even a single spark, one question, one image, one shiver of awe, then let it linger. Let it carry you through tomorrow. Share it with someone, or hold it silently like a secret gem in your pocket. Because wonder, like dark matter, does not always announce itself. It works quietly, invisibly, shaping the soul in ways we cannot measure. As we close, remember this: the search for dark matter is not only about physics. It is a mirror for our own lives. There are unseen forces within you too. Memories, longings, quiet strengths that hold you together when the visible parts of life seem fragile. Just as galaxies need their invisible scaffolding, so too do we rely on the unseen parts of ourselves: love, resilience, imagination. Perhaps in the end, dark matter is not only out there, but also within, reminding us that the most important things often cannot be seen. So my dear friend, rest now. Rest with the knowledge that you are part of a universe still unfolding, a story still being written. Rest with the comfort that mysteries are not threats, but gifts. And rest knowing that tomorrow and every day after, we will continue listening together for the whispers in the dark, for the quiet music of the cosmos. Until next time, stay gentle, stay curious, and never stop listening. This was Mind Peace, and I'm sending you love, care, and a quiet good night.